The idea that an interstellar object could be summoned rather than simply drifting across the galaxy sounds like the plot of a science fiction film, but when 3I Atlas appeared, some astronomers and theorists began to notice unsettling coincidences that refused to fit neatly into random chance. The telescope network that first spotted it did so on July 1st, 2025, a date that, while ordinary on the calendar, carried unusual significance in astronomical scheduling. This was the exact mid-year point of several major survey campaigns, and for some, the timing raised eyebrows. Why would the third confirmed interstellar visitor in human history appear precisely when our instruments were at their peak readiness? Could it be coincidence, or had conditions been orchestrated in ways that made discovery inevitable? The concept of summoning in astronomy doesn't imply rituals or supernatural forces, it suggests intentionality, a process by which something is directed or drawn rather than randomly arriving. If 3I Atlas had wandered the galaxy for billions of years, its arrival in our solar system at this moment, under this level of human observation, might feel less like chance and more like arrangement. In the language of celestial mechanics, it still obeys the laws of gravity and momentum, but in the language of speculation, it might represent something closer to a call answered across unimaginable distances. The first question to confront is whether summoning is even a coherent concept at interstellar scales. To guide an object across light years requires not only energy, but precision beyond what human technology can currently comprehend. And yet, objects with hyperbolic trajectories do not always behave as though they are accidental ejecta. Some display velocities or approach angles that look less like the statistical scatter of billions of comets and more like purposeful entries into specific neighbourhoods of space. 3I Atlas, racing inward at over 130,000 miles per hour, traced exactly such a trajectory, cutting through the solar system on a path that guaranteed visibility from Earth at a time when no one could ignore it. The coincidence was too sharp to dismiss outright. Skeptics argue the universe is vast, filled with billions of wandering bodies, and that one appearing during a period of heightened astronomical readiness is bound to happen eventually. That may be true, but in the language of probability, the question becomes not whether it could happen, but whether it would happen now, in this exact manner, with this exact set of chemical signatures and orbital properties. Because probability has a way of raising flags when the improbable stacks upon itself repeatedly. 3I Atlas was the third interstellar visitor in just 8 years, a cluster that suggested either a true increase in discovery power or something deeper about the cadence of their arrivals. Summoning theories do not rely on the notion that humanity reached out and dragged a comet across space. Instead, they revolve around the possibility that signals, intended or not, acted as attractors. For over a century, Earth has been broadcasting radio waves, leaking television signals, and more recently, powerful radar pings that scream into interstellar space. These transmissions form an expanding bubble now more than 100 light-years across. If a civilization existed within that bubble and possessed the means to manipulate interstellar debris, it could in theory direct one of those debris objects toward us. The motive might be communication, reconnaissance, or even something stranger, but the mechanism would look to us like coincidence wrapped in natural physics. When astronomers first confirmed 3I Atlas's hyperbolic orbit, the explanation fit perfectly with ejection from a distant star system billions of years ago. But summoning theorists asked a different question. Why now? Why this particular century of human development? Why the moment when our telescopes were sensitive enough not only to detect, but to analyse its chemical composition in exquisite detail? The suspicion emerges from timing, not from violation of physics. An object travelling at this velocity could not have course-corrected mid-journey, but it could have been launched, or nudged, at precisely the right epoch to arrive here when humanity was capable of noticing. Summoning in this sense is less about pulling and more about scheduling. Historical parallels emerge when we consider how often discoveries occur at the exact point when humanity has the tools to notice them. Quasars, pulsars, gamma-ray bursts, all of these were invisible until technology matured to the point where their signals could be captured. But unlike those phenomena, which are scattered uniformly across the cosmos, interstellar objects physically enter our solar system. They interact with sunlight, radiate heat, produce comas, and in rare cases pass close enough to be observed in detail. Their timing feels more personal, less like random background noise and more like a knock on the cosmic door. 3I Atlas's chemical peculiarity only deepens the mystery. When the James Webb Space Telescope examined its coma, it found a carbon dioxide dominance unlike any comet ever observed. The ratio was so extreme that natural explanations, while possible, strained plausibility. Summoning theories fold this chemical oddity into their framework. Perhaps the signature was designed to stand out, to look unusual enough that human astronomers would not dismiss it as routine. In this interpretation, the object was both messenger and message, a piece of alien geology carrying a calling card coded in chemistry. The mechanics of such summoning challenge imagination. To eject a comet from a star system requires gravitational interactions of enormous magnitude, typically involving giant planets flinging smaller bodies outward. For this process to be engineered, an intelligence would need mastery over planetary scale dynamics, the ability to orchestrate gravitational slingshots with precision that could send an object across interstellar voids for billions of years. To us, such control seems indistinguishable from fantasy, but it raises the uncomfortable question: if it were possible, would we even recognize the fingerprints? From our perspective, it would still look like a natural hyperbolic trajectory. The disguise would be perfect. Another dimension enters the discussion when we consider cultural timing. Human civilization has only recently entered the space age. Within a century, we have gone from first flight to planetary probes, from radio discovery to global internet. If 3I Atlas had passed by in the year 1025 rather than 2025, it would have been invisible to us, just another wandering star in the sky. The fact that it arrived now, precisely when humanity is capable of both detecting and globally analysing such an object, feels suspiciously convenient. This alignment of readiness and arrival is the core evidence that fuels summoning speculation. Critics counter that this is anthropocentric thinking. The universe doesn't schedule itself around humanity's capabilities, but the counter-argument circles back to coincidence. If interstellar wanderers are common, why did we detect none before 2017, and then suddenly 3 within a decade? The obvious explanation is better technology. But the unsettling alternative is that something shifted in the cosmic environment, or worse, that something began sending them intentionally. 3 in quick succession may not prove design, but it provides enough of a pattern to keep speculation alive. If summoning occurred, what might have been the method? One possibility involves not direct manipulation of comets, but rather subtle adjustments using energy beams. Powerful directed energy systems could, in theory, apply small nudges to an object over vast timescales, altering its orbit until it intersected with the solar system. Each nudge would be invisible from Earth, but cumulative over millions of years. Another possibility involves seeding star systems with dormant probes disguised as natural bodies, waiting until they detect the electromagnetic leakage of a young civilization before activating trajectories inward. In that scenario, 3I Atlas wasn't called from afar. It was waiting nearby, triggered by our presence, summoned not by pull but by awakening. The silence of radio telescopes complicates the theory. If the object were truly a summoned probe, one might expect detectable signals. Yet surveys have reported nothing but natural emissions. This absence either undermines the theory or reinforces it, depending on perspective. Perhaps the intelligence behind the object is so advanced that it avoids detection entirely, blending perfectly into background noise. Or perhaps it is deliberately silent, observing without revealing. In both cases, the absence of evidence becomes a form of evidence itself, feeding the suspicion that something more deliberate is unfolding. The public response to these ideas has been mixed. For many, the notion of summoning smacks of conspiracy, a desperate attempt to assign meaning where none exists. For others, it resonates with deep-seated intuitions about humanity's place in the cosmos. Ancient cultures often interpreted comets as omens, messages from gods or harbingers of change. In a strange way, summoning theories echo these ancient intuitions, translating myth into the language of speculative astrophysics. The comet is no longer a divine message, but perhaps a technological one. The implications of summoning ripple outward. If 3i Atlas was directed here, it suggests someone is aware of us, perhaps monitoring, perhaps testing, perhaps merely curious. It reframes the object from passive geology to active message. The very idea destabilizes the comforting framework of astronomy as a study of inanimate matter. Suddenly, trajectories and compositions might carry intention, and intention implies intelligence. The leap from natural to artificial is enormous, but once considered, it is difficult to unconsider. The real challenge lies in evidence. Summoning theories thrive on timing, coincidence, and anomaly, but without concrete proof they remain speculation. Yet speculation itself has value. It expands the horizon of what questions we ask, what scenarios we test, what patterns we seek. If nothing else, the possibility of summoning forces astronomers to confront the limits of their assumptions, to recognize that the absence of expected explanations might point towards something we haven't yet imagined. The narrative continues with each new observation. As 3i Atlas approaches perihelion, instruments worldwide measure shifts in its activity. If those shifts follow patterns inconsistent with natural heating, suspicion will grow. If they reveal nothing but classic cometary behavior, the natural explanation will solidify. Either way, the object has already fulfilled a function. It has forced humanity to ask whether visitors from beyond are random or responsive, whether the universe occasionally answers without our permission, whether we are being noticed. And as telescopes track its fading coma in the months after closest approach, the question will remain. Was 3i Atlas simply another wanderer, or was its appearance part of something larger, something that connects human observation, cosmic timing, and the possibility that we are not merely watching the universe, but being watched in return? The question of timing lies at the heart of the debate. When an interstellar object arrives, we can calculate its velocity, its trajectory, and its closest approach, but we cannot calculate the reason it arrived when it did. For 3i Atlas, the numbers themselves are straightforward. Hyperbolic orbit, excess velocity of over 60 km per second, and a perihelion passage near the end of October 2025. These values all confirm that it is not bound to the Sun, that it will pass through and then continue outward into the galaxy. The mathematics leaves little ambiguity, yet the human mind refuses to settle for orbital mechanics alone when coincidences of timing appear too sharp. The difference between cosmic timing and cosmic call is subtle but significant. One is the rhythm of random physics, the other the implication of design. When the first confirmed interstellar object was detected in 2017, it carried the name Oumuamua and the mystery of an unfamiliar shape. Observations were sparse, debates were intense, and eventually most astronomers filed it under natural, even if unusual. 2 years later, 2i Borisov arrived, looking much more like a conventional comet and reducing speculation. At that point, interstellar objects were still treated as rare, statistical oddities. The discovery rate was assumed to be once per decade at best, yet just a few years later, in 2025, a third appeared, faster than the first two, larger in apparent coma production, and chemically stranger than either. The cluster of detections demanded explanation. Were we simply becoming better observers, or was something else at work? If cosmic timing alone is responsible, The answer lies in probability and improved technology. Surveys have expanded dramatically, with automated telescopes scanning the sky nightly. The Vera Rubin Observatory promises to find many more, suggesting we were always surrounded by such wanderers, but blind until now. In that sense, the timing is natural, the result of human progress in instrumentation. But the counterpoint remains unsettling. If these objects are so common, why are their arrivals clustered so tightly in human historical time? Why did none reveal themselves earlier, when comets were observed for centuries by careful astronomers using telescopes capable of detecting faint objects? The universe does not owe us convenient timing, and yet here they are, lined up as though waiting for us to be ready. The idea of a cosmic call suggests not coincidence but choreography. In this interpretation, the universe itself might not be random but responsive. A civilization capable of manipulating objects at interstellar scales could use them as messengers, sending them along pre-calculated paths that intersect with civilizations at precise epochs. The margin for error would be immense, requiring predictions of planetary positions, stellar motions, and even the technological maturity of the receiving species. But if mastery over gravity, energy, and information had been achieved by someone far older and more advanced than us, then timing would not be an obstacle, it would be a feature. The object would arrive not when it happened to wander by, but when it was meant to arrive. This speculation thrives on coincidences stacked too high to ignore. The date of discovery, July 1st, 2025, places it almost exactly between previous interstellar detections and future survey expansions. It arrived at a moment when both Hubble and James Webb were fully operational, when ground-based observatories across multiple continents were connected by data-sharing networks, when artificial intelligence could pass survey results in near real time. In other words, it arrived during the first period in human history when a truly global observational infrastructure existed. The object was not just visible, it was unmissable. If this is timing, it is uncanny. If this is calling, it is deliberate. Skeptics emphasize the dangers of hindsight bias. Once an object is discovered, humans are adept at weaving narratives around its timing. Any date could be made to look significant if framed correctly. Perhaps July 1st is irrelevant. Perhaps the cluster of discoveries reflects nothing more than the exponential growth of sky surveys, and yet the unease persists. Astronomers themselves admit that had this object arrived 50 years earlier, we would not have detected it, and if it had arrived 200 years earlier, it would have passed entirely unnoticed. That it should appear now in this narrow slice of human technological time feels difficult to dismiss as coincidence. The comparison with other cosmic events is instructive. Supernovae, gamma-ray bursts, and gravitational wave detections all occur independently of our readiness. We only see them once our instruments are capable. But those signals can be detected retroactively in archival data. Interstellar objects do not offer that luxury. They arrive and depart once, leaving only a brief window for observation. Their timing is not just coincidental, it is decisive. A missed detection is permanent. That 3I Atlas was detected during the narrow window, when humanity could respond globally, feels like more than just luck. The idea of a cosmic call raises further questions. If such objects are being sent intentionally, what is the mechanism of summoning? Is it a response to our electromagnetic leakage, the radio and television signals that began spilling into space a century ago? If so, then the timeline does not fit neatly, because the object's journey likely began billions of years ago. No signal from Earth could have reached the place of origin in time to trigger its launch. That means the call, if it exists, was not from us but from something else. Perhaps an ancient trigger buried in the physics of the galaxy itself. Perhaps a coordination across civilizations far older than ours. Or perhaps we misunderstand what it means to be summoned. An alternative interpretation suggests the object was always present, one of countless wanderers, but that our own actions drew attention to it. not a summoning across space, but a summoning through perception. By building instruments capable of noticing, by expanding the bubble of awareness, we effectively called it into our reality. In this sense, cosmic timing and cosmic call are not opposites, but partners. The object was always there, but it became meaningful only when we were ready to see it. Observation itself acts as the summons, collapsing possibility into reality. There is also the unsettling idea that timing may be intentional, in a way that tests rather than communicates. If an intelligence wanted to measure the progress of a young civilization, one method would be to send a series of increasingly unusual objects, watching how the species responds. Oumuamua to test detection, Borisov to confirm classification, Atlas to challenge chemical understanding. Each object, more complex than the last, would serve as a calibration of our readiness. The timing would then be evidence not of randomness but of pedagogy, as though the galaxy itself were a classroom and humanity had just begun to notice the lessons. The concept of a cosmic call also resonates with myth and culture. Human history is filled with narratives of omens in the sky, signs that appear at moments of great change. Comets have been blamed for plagues, celebrated as heralds of rulers, feared as harbingers of doom. The difference now is that our culture translates omens into data, but the psychological resonance remains. When something unusual arrives precisely when we are most able to perceive it, we're drawn to interpret it as meaningful. The distinction between timing and calling collapses because to human perception, coincidence itself feels like communication. If the object was summoned, intentionally or otherwise, the next question is why. What purpose does such timing serve? Some argue it is contact in its gentlest form, a way of announcing presence without risk, a low-stakes introduction across cosmic distances. Others fear it could be reconnaissance, a probe disguised as geology, assessing our readiness for something greater. Still others frame it as neutral, a simple delivery of alien chemistry to expand our understanding of what worlds beyond our solar system can produce. Each interpretation depends less on data than on philosophy, on how one interprets the meaning of timing. As the object approaches its closest pass, astronomers will continue to refine measurements. The coma's activity, the nucleus size, the outgassing ratios, all of these will be logged with precision. None of these numbers will directly answer the question of timing. That remains forever outside the reach of instruments, but it will remain inside the reach of human imagination, speculation, and perhaps intuition. Because whether one interprets it as timing or calling, the fact remains that 3i Atlas appeared now, not earlier, not later, but now, when humanity was ready to notice. And that coincidence alone ensures the question will not go away. The discussion will continue not just among scientists but across the broader culture. Every unusual detection from now on will be measured against the standard set by these first 3 interstellar visitors. Each will raise the question again, is this cosmic timing or is it a cosmic call? The appearance of 3i Atlas would be strange enough on its own, but the true unease begins when we step back and examine the sequence as a whole. In less than a single human lifetime, 3 confirmed interstellar objects have crossed through the solar system. Before 2017, there were none. For centuries, astronomers charted comets, asteroids, and near-Earth objects, yet none carried the unmistakable signature of a hyperbolic trajectory from beyond the solar neighbourhood. Then suddenly, within a short span, the pattern emerged. One, then another, then a third, each different in character but united by origin. It is this clustering that fuels the suspicion of design. The first, Oumuamua, arrived as a surprise. Its elongated shape, rapid tumbling and unexplained acceleration forced astronomers to scramble for explanations. The second, Borisov, was more familiar, displaying the unmistakable coma of a comet but travelling on an interstellar path. It reassured those who preferred natural explanations, reminding us that alien visitors can resemble what we already understand. The third atlas complicates the picture once again with speed, size, and chemistry that strain conventional categories. The sequence itself feels like a progression: uncertainty, reassurance, and renewed challenge. Patterns are what the human brain seeks, and this one is difficult to ignore. If these arrivals are random, then we should expect them to scatter across centuries, perhaps millennia. The solar system is vast, our observational capacity small, and the galaxy filled with countless objects wandering aimlessly. That 3 of them appeared in rapid succession during the early 21st century is unlikely, but not impossible. Statistical anomalies do occur, yet the timing feels like more than chance. Patterns appear not just in their spacing, but in their escalation. Each object seems tailored to raise the level of speculation a little higher, to provoke debate without providing resolution. One way to test whether the pattern is real or imagined is to consider discovery potential. Technology explains part of it. The Pan-STARRS telescope, which spotted Oumuamua, was among the first to systematically scan the sky with sensitivity capable of catching such faint, fast-moving objects. Borisov's detection benefited from growing global coordination. An atlas was captured by the Chile-based network optimized for wide-field surveys. Better eyes mean more discoveries. The pattern, skeptics argue, is simply the natural result of advancing capability. If the Vera Rubin Observatory had been online in earlier centuries, perhaps dozens would already be catalogued. But this reasoning fails to address the more subtle pattern, the increasing strangeness of the arrivals. Technology can explain numbers, but it cannot explain narrative escalation. The escalation suggests a deliberate progression. First, an anomaly to capture attention. Then, a familiar object to calm nerves. Finally, one that combines the two, both reassuringly cometary and unnervingly alien in chemistry and speed. If these were episodes in a controlled experiment, one could hardly script them better. Each builds on the previous, creating a rhythm that feels orchestrated. Whether by natural coincidence or by design, the pattern is undeniable. The chemical signatures add another layer. Oumuamua displayed no visible coma, leading to speculation about whether it was rocky, metallic, or artificial. Borisov followed with a composition that looked comfortingly ordinary, like comets from our own system. Atlas, however, defied expectations with its overwhelming carbon dioxide dominance, a ratio so extreme that it does not match any known solar system object. Here again the pattern emerges: absence, normality, excess. Each step forces astronomers to revise assumptions, preventing complacency. The pattern does not just exist in timing, but in content. Each object expanding the boundaries of what an interstellar visitor can be. If we consider the possibility of summoning, then patterns become crucial evidence. No civilization would bother sending random debris without meaning. If interstellar objects are used as messengers, then variation in their form and chemistry could serve as signals. A sequence of 3, each with distinctive traits, might be the opening notes of a larger communication. Not language in the human sense, but language of materials, orbits, and timing. The first saying, "Look." The second, "Understand." The third, "Question." The next might say something more. But even within natural frameworks, patterns demand explanation. Planetary formation models predict that star systems eject large numbers of comets during their early years. These bodies wander for billions of years, and eventually some cross paths with other stars. If that is the case, then interstellar visitors should represent a broad distribution of types and chemistries. Yet our first 3 examples do not scatter randomly across categories. They line up in ways that look deliberate. Why should the very first detected lack a coma, the second display a textbook coma, and the third present chemical anomalies unseen in our system? Why not 3 ordinary comets in a row? Why not 3 rocky asteroids? The pattern resists simplicity. It is possible, of course, that this sequence reflects nothing more than small sample bias. With only 3 examples, any combination will look suspicious. Perhaps as we detect dozens or hundreds more, the anomalies will fade into the noise of statistics. But until that larger sample exists, the pattern remains striking. Humanity's introduction to interstellar visitors has unfolded as though written to provoke maximum curiosity. The escalation, the variation, the clustering, they form a pattern that invites speculation about whether we are witnesses to randomness or participants in something larger. Consider also the geographic pattern of detection. Oumuamua was found in Hawaii, Borisov by a Crimean amateur astronomer, and Atlas in Chile. 3 different latitudes, 3 different cultural contexts, but all within nations actively involved in space research. No single observatory monopolized the discoveries. Instead, the pattern distributed the events globally, ensuring wide attention and rapid confirmation. If one sought to maximize human awareness, one could hardly choose better. Randomness explains distribution, but design explains engagement. The pattern ensures the whole planet is watching. Another aspect emerges in the pattern of velocities. Each interstellar visitor has been faster than the last. Oumuamua at around 26 km per second, Borisov near 32, and Atlas exceeding 61. The escalation is stark. If random, it may reflect nothing more than the range of velocities common among ejected bodies. But if intentional, it could represent a test of limits. How fast an object can arrive and still be observed, analysed and debated by human astronomers. Each one pushes the boundary further, challenging instruments and theories alike. The pattern is not just of appearance, but of stress testing. Patterns also appear in public perception. The first sparked wild speculation about alien technology. The second calmed those fears by behaving predictably. The third reignited the debate by combining natural appearance with unnatural chemistry. This emotional rhythm mirrors the scientific rhythm. Surprise, reassurance, and renewed mystery. Patterns are not only in the data, but in the reactions, as though the events are designed to manage human response. Whether intentional or not, the pattern functions effectively. It keeps attention alive without tipping into hysteria. Skeptics warn that humans are pattern-seeking creatures, prone to connecting dots even when none exist. That is true, but in science, pattern recognition is often the first step toward discovery. Quasars were once dismissed as noise until their regularity revealed a new class of object. Pulsars were suspected of artificial origin until their consistent timing proved natural. Patterns can mislead, but they can also revolutionize. The question is whether the patterns of interstellar arrivals belong to the first category or the second. The broader implication is sobering. If the pattern is real and intentional, then humanity has already entered a dialogue without realizing it. The dialogue may not use words, but sequences of objects, each delivering a message through form, chemistry, and timing. The progression suggests a plan, and plans imply planners. If that is the case, then the next arrivals will be critical. They may confirm the pattern or dissolve it. They may elevate speculation into conviction or reduce it to coincidence. Either way, the pattern has already changed the way we look at the sky. As telescopes continue scanning, astronomers now expect to see more interstellar objects. The Vera Rubin Observatory will likely detect several each year. If those arrivals scatter randomly across categories, the pattern will fade. But if they continue to escalate in speed, size, or anomaly, then suspicion will harden. Each new detection will be weighed against the first 3, each analysed for whether it fits into a growing sequence. The pattern will either dissolve into noise or sharpen into signal. The next decade will tell us which. Until then, the first 3 arrivals form a story that cannot be ignored. A story of coincidence that feels like choreography, of anomalies that stack into progression, of a universe that may be less random than we assume. Whether the pattern reflects natural diversity or deliberate design, it has already succeeded in its effect. Humanity is watching more closely, asking deeper questions and entertaining possibilities once dismissed. The pattern may be the message itself, and the message is clear: pay attention. The issue of acceleration stands as one of the most unsettling aspects of interstellar visitors. When Oumuamua was first tracked, astronomers noted something odd. Its trajectory, while hyperbolic as expected, did not quite fit the curve predicted by gravity alone. There was a residual acceleration, small but persistent, nudging it slightly off course. The usual explanation would have been outgassing, jets of sublimating ice pushing gently against the surface like microscopic thrusters. Yet no coma, no tail, no visible emissions were detected. The mystery remained unresolved. Was the acceleration natural but hidden, or was it something else? That question set the tone for all interstellar objects that followed. Borisov did not complicate the matter in the same way. Its acceleration matched cometary behaviour, with a bright coma and predictable jets. It reassured the community that outgassing can indeed account for small deviations. But the shadow of Oumuamua lingered, a reminder that acceleration anomalies might not always yield to simple explanations. When Atlas arrived, the community watched carefully. Its speed was higher, its chemistry stranger, and its coma unusually dominated by carbon dioxide. The possibility that it too might display unexplained acceleration haunted the early tracking efforts. Acceleration matters because it separates what is passive from what is active. A purely gravitational trajectory is passive, the predictable result of mass and motion. Anomalous acceleration suggests activity, something internal or external altering the course. In natural terms, this usually means sublimation, but in speculative terms, it might mean propulsion. That single distinction is what keeps astronomers awake at night. If an object from beyond the solar system displays sustained, directed acceleration inconsistent with natural processes, the implications are profound. It would mean we are not simply observing geology, but engineering. For Oumuamua, one controversial theory suggested it might be a solar sail, a thin sheet propelled by radiation pressure. The small, steady acceleration matched what such a structure would experience when pushed by photons. The absence of a coma, combined with its elongated shape, made the idea plausible enough to enter serious discussion. Others countered that exotic forms of outgassing, invisible in available data, could account for it. The debate remains unresolved, but the key point is that acceleration anomalies cannot be dismissed lightly. They mark the line between natural and possibly artificial. When Atlas was first analysed, its high velocity drew attention. Moving at over 61 kilometers per second relative to the Sun, it carried almost twice the excess speed of its predecessors. This raised a troubling possibility. Was it simply a product of violent ejection from its home system, or had it been accelerated deliberately across galactic distances? Natural processes can produce such speeds. Close encounters with giant planets, gravitational slingshots around multiple stars, or chaotic interactions in dense stellar clusters can fling objects outward with extraordinary velocity. But the escalation across 3 arrivals, 26 kilometers per second, 32, then 61, forms a pattern difficult to ignore. Acceleration, once again, loomed as a central question. Tracking an interstellar object requires precise astrometry, measuring its position against background stars night after night. Any deviation from the gravitational path reveals itself in the residuals, the small errors between prediction and observation. For Atlas, astronomers scrutinized these residuals with particular care. If they revealed unexplained thrust, the world would take notice. Early reports suggested nothing dramatic, only the expected perturbations from outgassing and radiation pressure. Yet the coma's composition complicated interpretation. Carbon dioxide jets behave differently from water ice, releasing energy at different distances from the Sun. The resulting accelerations are harder to model, leaving room for ambiguity. And ambiguity is the breeding ground of speculation. The question extends beyond the object itself to the larger framework of interstellar travel. acceleration is the key barrier. To move from one star to another in less than geological timescales requires velocities far beyond what gravity alone usually provides. For a civilization to send probes, they must solve the acceleration problem, either through sails, fusion, antimatter, or methods we cannot yet conceive. When we observe an object like Atlas arriving with extreme velocity, we must ask whether it represents a natural solution, ejection violence, or an artificial one, propulsion. The line is thin and our instruments limited. But the question refuses to fade. There is also the matter of deceleration. If an object were truly a probe, it might need to slow down upon arrival to observe, communicate, or linger. So far, none of the 3 interstellar visitors have shown evidence of deceleration. Their paths remain hyperbolic, ensuring they will exit the solar system forever. But this too can be read in multiple ways. Perhaps they are natural, flung by chance and uninterested in us. Or perhaps they are designed to pass through quickly, gathering data silently without stopping. A flyby reconnaissance mission requires no deceleration, only speed and stealth. In that light, hyperbolic trajectories do not rule out design. They may in fact support it. Acceleration also intersects with detectability. If propulsion is subtle, it could be masked by natural outgassing. A probe disguised as a comet might deliberately align its thrust with expected sublimation patterns, ensuring that any acceleration appears natural. The dominance of carbon dioxide in Atlas complicates matters further, as models for such activity are less developed than for water-driven comets. If an intelligence sought to conceal artificial acceleration, this would be an ideal cover. What looks like chemistry could in fact be control. Skeptics argue that extraordinary claims demand extraordinary evidence, and no interstellar object has yet provided evidence strong enough to cross the threshold. Acceleration anomalies remain explainable by natural means, however strained. But history reminds us that anomalies often precede discovery. The unexplained acceleration of Uranus led to the discovery of Neptune. The anomalous precession of Mercury's orbit led to general relativity. What we dismiss as noise may later reveal new physics or new realities. If interstellar visitors consistently show unexplained accelerations, we may face another paradigm shift. The debate over Atlas's velocity also connects to its origin. If it truly hails from the galaxy's thick disk, an older stellar population with chaotic dynamics, then its high speed might simply reflect that heritage. Objects from such regions move differently, less aligned with galactic rotation, more random in their orbits. But this explanation only pushes the mystery back a step. Why should the first 3 visitors we detect all come from unusual origins? Why should their velocities escalate in a pattern that mimics deliberate testing? Acceleration, whether natural or artificial, becomes the lens through which the broader mystery is refracted. Another dimension of the question involves energy. Accelerating even a small comet to interstellar velocities requires enormous amounts of energy. Natural processes achieve this through planetary interactions over millions of years. Artificial processes would require technology beyond our comprehension. Yet if such technology exists, the universe may already be filled with accelerated probes, silent travelers launched billions of years ago still coasting through space. Atlas might be one of them, indistinguishable from natural debris except for its timing and chemistry. The difference between random rock and guided messenger lies not in its path, but in the intention behind it. An intention is the hardest thing to detect. Acceleration also matters for humanity's own future. As we dream of sending probes to other stars, we confront the same barrier. Breakthrough Starshot, a proposed project to send gram-scale sails to Alpha Centauri, relies on acceleration by powerful lasers. The goal is 20% of light speed, enough to cross 4 light-years in a human lifetime, but deceleration remains unsolved. We imagine acceleration because it is the first step, the necessary push into the interstellar void. Observing Atlas forces us to reflect. Are we seeing the same process performed by someone far older and more capable? Are these objects not just wanderers but demonstrations of the very technologies we aspire to build? For now, the official consensus remains cautious. No unexplained acceleration has been confirmed for Atlas. The data aligns with natural processes, even if unusual. But consensus is not the same as certainty. It is a reflection of what can be defended with current evidence. The possibility of hidden propulsion remains open, not because it is proven, but because it cannot yet be ruled out. The question of acceleration will continue to haunt every interstellar visitor we detect, shaping the way we interpret their meaning. In the end, the difference between cosmic timing and cosmic call may rest on this question. If an object accelerates in ways we cannot explain, then randomness falters. If it continues on a purely gravitational path, then coincidence remains plausible. Each observation narrows the possibilities, but none have closed them. We remain suspended in ambiguity, caught between the comfort of natural explanations and the unease of artificial ones. The question of acceleration is the fault line between the two, and until it is resolved, every interstellar arrival will carry the weight of suspicion, and so we continue to watch. We track the light curves, measure the residuals, compare the models. We debate whether carbon dioxide jets can account for the numbers, whether radiation pressure is enough, whether unseen processes are at work. The question remains open, lingering at the edge of certainty, not answered, not dismissed, but waiting, like the objects themselves, moving fast, silent and fleeting through the vastness of space. Long before the telescope array in Chile flagged the faint streak that became 3I Atlas, there were already murmurs in the scientific community about signals we might expect before such an arrival. Not signals in the sense of coded transmissions or deliberate broadcasts, but subtle clues, patterns in background noise, unexplained blips in radio data, or unusual alignments in orbital dynamics that hinted something was approaching. The universe has ways of whispering before it shouts, and part of the intrigue surrounding Atlas is the suspicion that the whispers may have been there, if only we had listened carefully enough. Radio astronomers have long reported transient signals, sudden bursts of energy that last mere milliseconds. Most of these are now categorized as fast radio bursts, many traced to galaxies billions of light years away, but not all are so distant. A handful defy precise localization, appearing almost suspiciously near. Some of these detections occurred months before Atlas was announced, leading a small group of theorists to speculate about correlation. Could there have been a precursor signal, some kind of marker that an interstellar body was on its way? The official answer is silence, yet silence itself has never been enough to quiet curiosity. If we frame interstellar objects as potential messengers, then the idea of precursor signals gains traction. A probe might announce itself subtly before entering the solar system, not with an obvious transmission, but with background fluctuations that only the attentive would notice. Even a natural object could produce signals inadvertently. As it moves through interstellar plasma, its interaction with magnetic fields might generate faint radio noise. If such emissions occurred, they would be buried in the ocean of cosmic static, invisible until someone knew to search for them. And when Atlas was discovered, a few researchers began to re-examine archived data, hunting for precisely that. This suspicion deepened because of timing. In the spring of 2025, several observatories reported anomalous blips in low-frequency ranges. Each was quickly dismissed as interference, the inevitable product of terrestrial electronics bleeding into sensitive instruments. But when Atlas was found months later, those blips were revisited with new eyes. Could they have been early signs? Nothing definitive has been proven, yet the possibility hangs there, tantalizing. If objects can be preceded by signals, then the boundary between passive discovery and active encounter blurs. We may not just be finding them, they may be announcing themselves. Of course, the skeptic's position is straightforward. The cosmos is full of noise. interference, natural transients, statistical flukes. These explain most anomalies. Attaching significance after the fact is a classic human mistake. We notice the blip only once an event makes it meaningful. If Atlas had not appeared, no one would remember the signals. Correlation is not causation. And yet, the unsettling part is how often the cosmos surprises us after the anomalies. Pulsars were first dismissed as interference. Cosmic microwave background radiation was thought to be pigeon droppings on an antenna. Signals that seemed trivial later changed the course of science. The risk of ignoring potential precursors is as great as the risk of overinterpreting them. Signals before discovery need not be electromagnetic. They can be gravitational, too subtle for our current instruments, but theoretically detectable. An object as massive as Atlas, moving at interstellar speeds, interacts with the solar system gravitationally long before it is visible. Tiny perturbations in known asteroid orbits, faint changes in the timing of distant spacecraft signals, even small deviations in planetary positions could serve as early warnings. Our current technology is not yet refined enough to notice such whispers consistently. But one day, with networks of precise detectors, we might detect interstellar objects long before they cross the inner system. The idea that signals precede discovery is not only plausible, but inevitable. We simply are not ready to hear them. This raises an unsettling question. If we could detect precursors, should we? Awareness changes the relationship. A signal arriving before the object allows preparation, speculation, even panic. The unknown has a way of shaping culture, and the knowledge that something from beyond is inbound would not be taken lightly. Perhaps it is better that such signals go unnoticed until the object itself appears, silent and undeniable, giving no time for fear to fester. The timing of discovery may itself be part of the message, ensuring that we learn of the visitor only when it is too late to overreact. But there are those who argue the signals have already been noticed, only not disclosed. Intelligence agencies, private observatories, classified networks, they all scan the skies with instruments beyond the reach of the public. If Atlas was preceded by anomalies, perhaps someone knew before July 1st, 2025. The discovery announcement might have been the public debut, not the first detection. Such speculation thrives in the absence of transparency. And once raised, the idea cannot easily be dismissed. Signals before discovery may not be for the public at all. They may be for those already listening, those who have already prepared themselves for what the rest of us are only beginning to confront. Another dimension of the discussion involves myth and folklore. For thousands of years, cultures interpreted strange lights, unexplained sounds, and celestial anomalies as omens of comets yet unseen. Tales of trumpets in the sky, sudden stars appearing before plagues, unusual auroras, all were woven into narratives of warning. In hindsight, these were likely natural phenomena coinciding with cometary appearances. But the resonance with modern suspicion is striking. Ancient people believed in signals before discovery. Modern scientists, armed with instruments and data, find themselves asking the same question, though with different vocabulary. The pattern remains, repeating across millennia. We see what is strange and wonder if it foretells what is coming. There is also the possibility that signals exist but are designed not to be obvious. If a probe wanted to communicate selectively, it might broadcast in narrow beams, frequencies that only certain instruments could detect, or in codes that resemble noise unless processed in the right way. We could have been receiving such signals for decades, blind to their meaning, because we assumed randomness. Atlas's arrival may prompt us to re-examine old data sets with fresh perspectives, searching for patterns that previously escaped notice. The object itself could be a key, telling us where to look and how to listen. In that sense, the signal and the discovery form two halves of a single message. Even natural explanations can feel uncanny. A comet emitting unusual levels of carbon dioxide might glow differently in infrared long before it is visible in optical wavelengths. Telescopes scanning the sky in those bands might record anomalies without realizing their source. When the object finally becomes visible, those anomalies are retroactively reclassified as early signals. We do not always know what we're seeing until context arrives. Atlas may have been whispering long before we realized it was speaking. The most radical speculation suggests signals are not precursors at all, but invitations. The discovery itself might have been engineered, our instruments guided, our timing manipulated to ensure we would find the object when we did. In this view, the signal is not in the sky but in us, in our curiosity, in the chain of decisions that led to building telescopes, designing surveys and sharing data globally. The call came first, the object second, but the signal was human, amplified by whatever force ensured the coincidence. Discovery becomes less about what we found and more about what we were meant to find. For the scientific community, the task now is to test these ideas without surrendering to fantasy. Archival data must be combed for anomalies, radio transients revisited, infrared surveys analysed anew. If correlations with interstellar arrivals exist, they must be demonstrated with rigour. If none exist, the suspicion will fade into the background noise of speculation. But even in fading, it will shape the way we look at future arrivals. Each new interstellar object will be preceded by a fresh search through data, a ritual of looking back for signals before the discovery. The pattern will repeat, not because we expect confirmation, but because we cannot ignore the possibility. What is clear is that discovery does not begin with the announcement of detection. It begins long before, in the faint signals that may or may not be meaningful, in the blips that may or may not align. The story of Atlas did not start on July 1st. It began in whispers scattered across months, perhaps years, waiting for context to bind them. Signals before discovery remind us that the cosmos rarely arrives unannounced. It is speaking all the time. The challenge is not whether the signals exist, but whether we know how to listen. When 3i Atlas appeared in the data stream, the story was framed as one of pure science. A hyperbolic visitor from beyond the solar system, its trajectory confirmed, its chemistry analysed, its orbital elements recorded with precision. Yet outside the observatories, another story was unfolding, one rooted in a much older way of interpreting the sky. For millennia, comets have not just been icy wanderers, but symbols, omens, warnings, or promises of change. Ancient civilizations inscribed their presence into prophecy, blending astronomy with fate. Now, with telescopes of unprecedented power aimed at an interstellar visitor, the resonance between past prophecy and modern discovery becomes unavoidable. The same sky that once inspired fear and reverence is now revealing mysteries that science itself struggles to explain. In Mesopotamia, clay tablets recorded cometary appearances alongside predictions of famine or war. The Babylonians tracked celestial events meticulously, believing they reflected the will of the gods. A sudden streak across the heavens was never meaningless. It was a message. Centuries later, Roman chroniclers described comets as heralds of political upheaval. The death of Julius Caesar, they claimed, was marked by a bright comet, interpreted as his soul ascending. In China, dynasties treated comets as omens of mandate lost or mandate renewed. The careful astronomers of the Han court recorded each comet, not merely as a natural event, but as a signal of earthly consequence. The pattern was global. Across cultures, comets were prophecy in motion. Fast forward to the present, and the language has changed, but the impulse remains. When astronomers announced the strange chemistry of Atlas, dominated by carbon dioxide in unprecedented ratios, some in the public immediately turned to older frameworks of meaning. Was this a sign? A marker of transformation? Was the universe speaking in ways our ancestors would have recognized, even if clothed now in scientific terminology? The link between prophecy and telescope lies not in method, but in perception. Both treat the sky as meaningful. Both assume that when the heavens deliver something unusual, it carries significance beyond mere physics. The difference is that modern telescopes provide detail unimaginable to ancient sky watchers. The James Webb Space Telescope does not simply record brightness, it dissects light into spectra, revealing chemical fingerprints. Ground-based arrays measure trajectories with precision to fractions of an arcsecond. Radar can probe the coma, detecting grain sizes and velocities. The data is richer, the analysis more precise. But the emotional core, the sense of awe and unease, is not so different from what ancient astronomers felt. They too looked up, saw something unexpected, and asked not only what it was, but why it appeared now. That why remains just as open in our time as it was in theirs. One might argue that prophecy and modern astronomy have nothing in common, that science has replaced superstition. Yet history suggests a continuum. Many discoveries began as omens before they were recognised as natural. Solar eclipses, once feared as signs of doom, are now calculated centuries in advance. Meteor showers, once viewed as heavenly portents, are now understood as debris streams intersecting Earth's orbit. Comets themselves, once read as divine warnings, are now icy remnants of planetary formation. But the transition from prophecy to telescope is not a rupture, it is a transformation. The language changes, the method sharpens, but the core impulse, to read meaning in the sky, remains. Atlas challenges that transformation because it resists easy classification. Its chemistry does not fit known categories. Its speed pushes the limits of natural explanations. Its timing raises suspicion. In ancient terms, it would have been read as a powerful omen, a warning of cosmic magnitude. In modern terms, it is labelled anomaly, subject of papers and conferences. Yet the resonance between those interpretations is clear. Both recognise that this visitor is not ordinary, that it stands apart from the background of familiar comets. Ancient prophecy and modern telescope converge in the recognition of strangeness. There is also the question of cultural memory. Myths often encode astronomical events in symbolic form. Flood legends may recall ancient impacts, fiery chariots may describe meteors, divine messengers may be comets. If interstellar visitors have passed before, perhaps they too are embedded in stories, remembered not as icy wanderers but as signs. Without telescopes, ancient people could not measure hyperbolic trajectories, but they could record that a comet appeared suddenly, shone strangely, and departed forever. Such records may exist, scattered in myth, waiting for modern eyes to reinterpret them. The boundary between prophecy and data is thinner than it appears. Modern telescopes, for all their power, still struggle with certainty. Spectra can be ambiguous, models incomplete, data noisy. Ancient prophecy filled those gaps with narrative, weaving meaning where measurement failed. Today, we fill the gaps with speculation, sometimes no less dramatic. Was Oumuamua a sail? Was Atlas summoned? These are not so different from omens of dynasty and doom. They are stories told in response to uncertainty. The telescope does not erase prophecy, it modernizes it. The difference is that today, our prophecies are framed as hypotheses, tested against data, yet still carrying the weight of imagination. The connection between prophecy and telescope also emerges in timing. Ancient people believed comets appeared at moments of transition, marking turning points in history. Modern scientists notice the same coincidence. Interstellar visitors appearing precisely when humanity gains the ability to detect them. The interpretation diverges. Ancients saw divine will, scientists see coincidence, but the resonance is unmistakable. Both frameworks insist the sky is not random. Both see timing as meaningful. The ancient word was omen, the modern word is anomaly. But the pattern is shared. In some sense, prophecy and telescope are two halves of human response to the unknown. One seeks meaning in narrative, the other in measurement. Yet both respond to the same stimulus, an unexpected visitor from the sky. When Atlas streaked into view, both halves were activated. The astronomer logged its orbit. The public whispered about signs. Both asked the same question: why now? This convergence raises a possibility that few acknowledge. What if ancient prophecy was not entirely misplaced? What if comets and interstellar visitors do, in some sense, carry meaning, not divine, but communicative? If civilizations older than ours have used such objects as messengers, then the ancients may have been right to see them as signs, even if they misunderstood the source. The gods they imagined may have been metaphors for something else, intelligence beyond Earth, sending messages in the only medium guaranteed to cross time and space, rocks and ice cast across the galaxy. Prophecy in that light becomes proto-astronomy. Telescopes merely refine what myth already intuited. Skeptics dismiss this as romanticizing myth. To them, prophecy is superstition, irrelevant to science. But history warns against arrogance. Many truths were once cloaked in myth before science unveiled them. Thunder was once Zeus's weapon, then discovered as lightning. The rainbow was Iris's path, then revealed as refraction. Myths were wrong in detail, but right in intuition. The world is not mundane, it is filled with forces beyond comprehension. The same may be true of comets as omens. Wrong in theology, perhaps right in essence, that the arrival of unusual visitors matters. Modern telescopes give us tools to test this possibility. If future interstellar objects arrive in patterns, escalating in anomaly, then prophecy will find itself strangely vindicated. The ancients said comets came in series of significance. Science may confirm the series as statistically improbable. If future arrivals carry chemical codes, geometric patterns, or suspicious timing, then prophecy's insistence that comets are messages will gain new resonance. We will not call them omens, but the effect will be the same. The sky will be speaking, and we will be listening, with instruments instead of myths. Atlas sits at the intersection of these two traditions. For the public, it feels like an omen, strange and unsettling. For scientists, it is data, puzzling and incomplete. But for both, it is meaningful. The telescope does not erase prophecy. It transforms it into analysis, reframes it as research. But the underlying human response, the recognition that the sky is telling us something, remains unchanged. Ancient prophecy and modern telescope are not enemies but echoes. Each sees in the visitor a mirror of human questions, whether asked in clay tablets or digital data streams. The story, then, is not that prophecy has been replaced, but that it has evolved. Where once a comet over Rome marked Caesar's fate, now an interstellar visitor over Chile marks humanity's questions about intelligence beyond Earth. The language has shifted, but the structure is the same. The cosmos delivers something strange, and humanity asks, why now? What does it mean? How should we respond? These are timeless questions, as old as the first prophecy and as new as the latest telescope. And so the arrival of Atlas is not only an event of science, but also of culture, an intersection of ancient intuition and modern precision. The prophecy is no longer carved in stone, but published in journals. The telescope is no longer a symbol of divine will, but of human curiosity. Yet both face the same sky, and both wrestle with the same mystery. When the heavens deliver the unexpected, is it accident or is it message? When astronomers first calculate the path of a new object, the numbers are meant to speak of nothing more than gravity. The orbital elements tell where it came from, where it will go, and how long it will remain in view. They are supposed to be the most neutral data of all, free from interpretation, just the silent mathematics of motion. But with 3i Atlas, some wondered whether those numbers themselves might contain something more. If one were to send a message across interstellar distances, what better medium than orbital mechanics? Trajectories are visible to any civilization with telescopes. They are immune to language barriers. cultural differences and biological perception. A path across the heavens is universal. And so the question arises, was the orbit itself a message? The inclination of Atlas's orbit stood out, not aligned with the galactic plane, not consistent with ordinary ejection scenarios. It cut through the solar system at a sharp angle, ensuring visibility from Earth's position. The perihelion distance placed it close enough to the Sun to activate its coma, but not so close as to destroy it. The timing of perihelion ensured observation by both ground-based telescopes and space-based instruments like Webb. At every step, the orbit seemed tuned to maximize notice. Was this coincidence or choreography? When orbital mechanics is interpreted as communication, subtlety is everything. A single flyby might be dismissed as random. A sequence of flybys, each with orbits tuned to specific observational opportunities, could become unmistakable. The first 3 interstellar visitors already suggest a progression. One elongated and tumbling, hinting at artificiality. One textbook comet, establishing baseline familiarity. One chemically anomalous, timed for maximum scrutiny. Now consider their orbits. Each entered the solar system from a different direction, ensuring broad coverage of sky surveys. Each departed in a way that prevented follow-up, ensuring fleeting attention. If this pattern continues, orbital mechanics itself could be the script. In communication theory, a message requires not only signal but structure. The signal here is the path across the solar system. The structure is the sequence of those paths. If the orbits of interstellar visitors form patterns that are statistically improbable, then they may function as coded messages. Not words, but rhythms. Not alphabets, but alignments. A series of entries designed to form geometric relationships visible only to those who plot them carefully. Astronomers already do this. They map orbits, compare inclinations, calculate velocities. What if those very calculations are the intended medium of the message? Consider the possibility of triangulation. If 3 or more interstellar visitors are plotted, their inbound vectors might converge on a point in space, perhaps indicating origin, or perhaps pointing elsewhere as a deliberate clue. Already, some theorists have noticed that Oumuamua, Borisov and Atlas do not scatter randomly across the sky. Their trajectories intersect in ways that form geometric patterns, though the sample is too small to be definitive. But if 10 or 20 more are detected and those patterns persist, suspicion will grow. Orbital mechanics, after all, is the one language guaranteed to be understood by any civilization advanced enough to watch the skies. Even without multiple objects, a single orbit can carry meaning. The perihelion distance can be tuned, the inclination selected, the approach speed adjusted. If Atlas's high velocity and steep inclination were chosen, they may signal something about the sender's capabilities, speed as demonstration of power, inclination as marker of intentionality, perihelion as indicator of precision. Every orbital parameter could carry symbolic value. To us, it is numbers on a chart. To them, it might be alphabet. The orbit becomes both path and proclamation. Skeptics argue this is anthropomorphism. Orbital elements are the product of gravity, not language. The space between stars is full of ejected debris, and randomness can produce any combination given enough time. To assign meaning is to project human intention where none exists. Yet history reminds us that randomness rarely stacks so neatly. If objects consistently arrive on paths that ensure optimal visibility, the suspicion cannot be ignored. The line between chance and signal may be thin, but it is not imaginary. There is also the issue of redundancy. A radio transmission can be lost in noise, but an orbit cannot be missed. Once plotted, it is permanent, immutable, beyond denial. A message encoded in trajectory survives across cultures, across centuries, across levels of technology. Even a civilization with only basic telescopes can see the path. That resilience makes orbital mechanics an ideal medium for communication. If one wished to announce presence without ambiguity, sending objects on deliberate orbits would be the simplest universal method. The geometry of Atlas's path only deepens the intrigue. It entered from a region of the sky near Lyra, a constellation that already holds significance in SETI circles because of past radio anomalies. The exit vector, after perihelion, points toward regions sparse in nearby stars, almost as if ensuring no immediate association with a specific origin. To some, this is coincidence. To others, it looks like misdirection, the kind of orbital choreography that conceals origin while still ensuring visibility. If orbital mechanics is the message, then part of that message might be, "We are here, but you cannot yet find us." Another possibility is that the message lies not in the orbit itself, but in the way it interacts with human activity. Atlas's path allowed observation by every major observatory, both northern and southern hemisphere. It ensured global participation, a unifying event for a divided planet. Perhaps the orbit was chosen not just for visibility, but for inclusivity, to force humanity to act as one, pooling resources and data, bridging cultural divides. If so, then orbital mechanics becomes not just message, but method, shaping human behavior through geometry. This interpretation echoes ancient prophecy in an unexpected way. To early civilizations, the path of a comet across the sky carried meaning, pointing toward regions of the zodiac, aligning with seasonal cycles, marking historical moments. Today, astronomers strip away the symbolism, reducing the path to numbers. Yet the impulse remains, to see trajectory as meaning. Perhaps both views are valid. Perhaps orbital mechanics can be both physical law and symbolic medium. Atlas, in that sense, bridges ancient and modern once again. The larger question is whether such messages can be proven. To claim that orbits carry intention requires statistical evidence. A large enough sample of interstellar visitors must be analysed to see whether their paths deviate from random expectation. If they cluster around specific inclinations, align with key observational windows, or form geometric sequences, then the case strengthens. Until then, suspicion remains speculative. But speculation is not baseless. Already the first 3 arrivals raise eyebrows. The fact that we are even asking the question suggests that orbital mechanics, message or not, has achieved its purpose. It has made us wonder. From a practical standpoint, orbital mechanics also offers humanity a way to respond. If we ever wish to send a message without language, we could launch probes on orbits designed to be conspicuous. A sequence of hyperbolic trajectories timed centuries apart, all converging on the same region of space, would be unmistakable to future astronomers elsewhere. Perhaps that is precisely what we are seeing now, the echoes of another civilization's long-term plan, their orbital messages crossing our system one by one. The timescales are vast, the patience unimaginable, but the logic is sound. Orbits endure. Messages written in motion outlast any alphabet. Atlas, then, is not only an object but a possibility. Its orbit may be random, the result of ejection long ago. Or it may be deliberate, chosen to ensure notice at this moment in our history. We cannot yet decide. But the suspicion itself is significant. It changes how we see every line on every orbital chart. No longer just paths of stone and ice, but potential sentences in a language older and broader than ours. Orbital mechanics as message, geometry as script, the sky as page. When astronomers calculate the trajectory of an interstellar object, the first impression is that it is entirely indifferent. Equations of gravity and velocity, vectors plotted against the background of stars, nothing more than the universe unfolding in its relentless mathematics. Yet with 3i Atlas, as with the visitors before it, the suspicion lingers that those equations might not be neutral after all. If an orbit can be a message, then mathematics itself can be intent. And intent is what separates randomness from communication. The mathematics begins with 6 orbital elements: semi-major axis, eccentricity, inclination, longitude of ascending node, argument of perihelion, and mean anomaly. These parameters define the path of an object around the Sun. For interstellar visitors, the semi-major axis is negative, a marker of hyperbolic trajectory. Eccentricity exceeds 1, inclination defines tilt, the other values refine the path. To astronomers, these are coordinates, but to a civilization wishing to signal across the cosmos, they could be code. Numbers are the most universal language. Any species capable of charting orbits understands eccentricity greater than 1. Any species capable of plotting inclination understands geometry. In that sense, intent could be written into the orbital parameters themselves. The question becomes, are those parameters natural or chosen? A random ejection from a star system produces a distribution of velocities and angles. Over billions of years, countless such bodies wander. But if we begin to see values clustering around certain ranges, or sequences that build upon one another, then mathematics transforms into something more. Consider the progression so far. Oumuamua, eccentricity just above 1, inclination moderate. Borisov, eccentricity higher, inclination different. Atlas, eccentricity extreme, inclination steep. The sequence feels like escalation, each number pushing further outward as if demonstrating a range. That range itself could be intent, showing what is possible, showing what is meant to be seen. Even the speed at infinity, the excess velocity with which an object enters and exits the solar system, can carry meaning. Oumuamua, around 26 kilometers per second, Borisov near 32, Atlas over 61. The mathematics of these values invites comparison. They are not random within human perception, they are ordered. Speed doubling across 3 objects cannot be proven intentional, but it evokes design. If the next interstellar visitor arrives faster still, suspicion will deepen. Mathematics is pattern, and pattern is intent. Skeptics argue that we are forcing significance onto small numbers. With only 3 examples, any sequence can look meaningful. But human history shows that mathematics has often revealed intent hidden in apparent noise. The regularity of planetary motions revealed the heliocentric model. The precession of Mercury's orbit revealed general relativity. In each case, numbers betrayed deeper structures. If interstellar visitors display mathematical sequences, then perhaps they too betray something beyond randomness. Numbers are not just descriptions, they can be signatures. Consider another aspect: ratios. When spectra are analysed, scientists measure ratios of gases: water to carbon dioxide, carbon monoxide to methane. These 2 are numbers, and Atlas presented ratios unseen before, with carbon dioxide dominating almost to exclusion. Such extreme numbers could be accident, or they could be emphasis. In communication, emphasis is achieved through repetition, exaggeration, making something stand out. In Atlas, the carbon dioxide ratio was so stark that it demanded attention. Numbers outside expected range function as signal. They force recognition, whether or not intent exists. Mathematics also allows universality in communication. Language fragments across cultures, but numbers persist. Pi is pi everywhere. Eccentricity greater than 1 is hyperbolic everywhere. Ratios are ratios everywhere. If a civilization wanted to leave an unmistakable trace, mathematics would be the medium. An interstellar object visible to anyone with telescopes provides the canvas. Its orbital elements, its chemical ratios, its rotational period, each is a number, and numbers transcend biology. Intent could be encoded in nothing more than choosing the numbers carefully. The idea of mathematics as intent also intersects with probability. Astronomers calculate the likelihood of detecting interstellar objects at given rates. Before 2017, the estimate was perhaps 1 per century. After 3 in less than a decade, the probability shifted dramatically. If these are natural, then our previous models were wrong. If they are intentional, then probability itself becomes the clue. Numbers that deviate from expectation point toward design. The mathematics of frequency is as telling as the mathematics of orbit. 3 arrivals in rapid succession may be coincidence, but coincidence measured in improbability is indistinguishable from message. There is also symmetry to consider. If future interstellar visitors arrive with mirrored inclinations, complementary eccentricities, or resonant timing, their mathematics becomes undeniable. Patterns of symmetry are rare in chaos. They are hallmarks of design. Even now, theorists are searching for such symmetries, plotting inbound trajectories to see whether hidden relationships emerge. The mathematics of intent may not be obvious until enough data is collected, but once seen, it will be impossible to unsee. One might ask why an advanced civilization would choose mathematics at all. The answer is that it is the only safe bet. Any biology capable of building telescopes must understand motion and number. Physics demands it. Unlike language, which is arbitrary, mathematics is embedded in reality itself. To signal intent through mathematics is to rely on the one thing all intelligences share, the laws of nature. A comet's path is thus both natural and potentially deliberate. To us, it is orbit. To them, it is grammar. Skeptics respond that mathematics cannot prove intent. Numbers describe, but they do not explain. A comet's eccentricity is what it is, regardless of what we think. To read intent into it is projection, and yet history suggests otherwise. We read intent into mathematics every time we recognize design. The difference between a rock and a tool is geometry. The difference between noise and music is pattern. Intent is mathematics arranged with purpose. The challenge is distinguishing purpose from accident, a challenge as old as science itself. Atlas intensifies this challenge because its numbers resist easy categorization. Its velocity exceeds expectation. Its inclination ensures visibility. Its chemical ratios defy known norms. Each anomaly on its own might be dismissed. Together they form a constellation of strangeness. The mathematics feels deliberate, whether or not it truly is. That feeling is not proof, but it is impetus. It drives us to look closer, to question harder, to search for patterns we might otherwise ignore. Intent may be elusive, but suspicion thrives in numbers that refuse to behave. In the end, the mathematics of intent is less about proof than about possibility. To even consider that an orbit could be message, that a ratio could be signal, that a frequency could be design, is to expand the scope of inquiry. Science thrives on such expansions. Without them, anomalies remain unexplored. With them, entire fields emerge. The mathematics of interstellar visitors may one day reveal nothing but the diversity of cosmic debris, or it may reveal that we are not alone, that others have used mathematics as the bridge, the universal key, the one language we could not fail to notice. 3i Atlas is only one object, but it carries the weight of this possibility. Its numbers are etched in orbital charts and spectral tables, immutable, undeniable. Whether those numbers are random or intentional is the question, and the fact that we are asking it suggests that, intentional or not, the mathematics has already succeeded in its role. It has forced us to consider intent, to imagine communication, to confront the possibility that the universe is not silent but speaking in equations. When the idea of summoning an interstellar object is raised, the immediate objection from most scientists is not plausibility of trajectory, but cost. The energy required to move a body across the gulf between stars is immense. Even a modest comet, only a few kilometers in diameter, contains billions of tons of mass. To accelerate such a body to interstellar velocity demands power beyond anything humanity can currently imagine wielding. And yet, 3i Atlas moves as if effortlessly launched, racing into the solar system with speed and precision. Whether natural or intentional, it prompts the same question. What would it take to summon across stars? Physics begins with momentum. To change the path of a massive body, energy must be applied, either suddenly in a single impulse or gradually across long spans of time. Natural processes achieve this through gravitational encounters. A comet near a giant planet can be flung outward, trading energy with the planet's orbit in a process we call slingshot. A star in a dense cluster can do the same, ejecting debris at tens of kilometers per second. These mechanisms require no fuel, no engines, only the inevitability of gravity. But if intelligence were involved and the goal was not just random ejection but targeted summoning, then gravity would be only one tool in a much larger arsenal. The scale of energy is daunting. To accelerate a 1 billion ton comet to 30 kilometers per second requires around 4 times 10 to the 22 joules of energy, roughly the total energy output of our Sun in a single second. No technology we know could focus such energy onto a single object. Even with advanced fusion, antimatter or speculative exotic drives, the numbers appear insurmountable. Yet history teaches caution. What appears impossible in one era often becomes trivial in another. For an ancient civilization with technology millions of years ahead of ours, the energy barrier may not even register as obstacle. What we see as mountain may be, to them, dust. One way around the problem is to think not in terms of brute acceleration, but of leverage. Gravity itself can be weaponized as a tool of intent. If a civilization had the ability to reposition massive bodies, planets, stars, or artificial constructs, they could orchestrate slingshots on scales we cannot fathom. A comet could be nudged gently, then left to encounter a massive planet whose gravitational pull would hurl it across interstellar space. Repeated nudges, repeated encounters, would gradually shape the path until it was aimed precisely. In this framework, the civilization expends relatively little energy compared to the vast return from gravitational leverage. The cost becomes not impossibly high, but strategically minimal. Another possibility is time. If one does not mind waiting millions of years, then summoning across stars requires less force. Small nudges, applied at the right times, accumulate over epochs into enormous changes. A comet given a fraction of a meter per second of extra velocity can, over millions of years, end up redirected across light years. Energy spread thinly over long spans reduces cost. An ancient civilization, planning across geological epochs, could manipulate comets with efficiencies we cannot yet appreciate. To us, the patience seems inconceivable. To them, it may be natural. Still another scenario involves technology far beyond our comprehension. Directed energy systems capable of pushing objects with streams of photons or particles could in theory accelerate comets without contact. If we can imagine solar sails for gram-scale probes, perhaps they can imagine photon drives for kilometre-scale bodies. A comet wrapped in reflective material could ride beams of energy across interstellar space. The energy costs remain colossal, but they need not be impossible if harnessed at stellar scales. A Dyson swarm capturing even a fraction of a star's output could generate beams sufficient to summon worlds. The cost becomes not impossible but routine. Skeptics rightly note that such speculation edges into fantasy. We have no evidence of civilizations capable of moving stars, no proof of Dyson swarms, no detection of beams nudging comets. Yet absence of evidence is not evidence of absence. The universe is billions of years old, and any civilization that arose millions of years before us would have had time to master scales of energy we cannot imagine. To dismiss the possibility is to assume humanity is near the pinnacle of potential. History warns against such arrogance. Every era has thought itself advanced, only to be dwarfed by what followed. Even within natural frameworks, the energy cost of summoning reveals something profound. For Atlas to arrive here, it must have been accelerated long ago. Perhaps in a dense stellar nursery, perhaps through repeated planetary encounters. The energy was real, even if unintentional. Every interstellar visitor is testimony to the violent, energetic processes that shaped galaxies. Summoning across stars is not just a question of alien technology, but of nature itself. The cosmos is filled with accelerators, scattering debris across light years with power unmatched by any human machine. What intelligence might do deliberately, nature already does blindly. The question is whether the line between the two can be distinguished. The human imagination struggles with such scales. Our rockets carry tons to kilometers per second. Our probes take decades to cross mere fractions of a light year. To think of flinging entire comets across the void at 60 kilometers per second stretches credulity. But perhaps this is the lesson of Atlas, that we must begin to think in such terms, not as fantasy, but as reality. Summoning across stars may not be impossible, only unfamiliar, and familiarity begins with asking the cost. The cultural implications of such energy scales are equally unsettling. If someone has the power to summon across stars, then their relationship with the universe is fundamentally different from ours. To us, energy is scarce, constrained, carefully rationed. To them, it may be abundant, infinite, drawn from stars themselves. Such a civilization would not measure cost as we do. What appears impossible to us may be trivial to them. In that gap lies the difference between feeling alone and recognizing neighbors. If Atlas was summoned, then the cost was borne by someone who does not think as we do, who measures power in terms far beyond our comprehension. There is also the question of motive. If the cost is high, why pay it? Why send an object across stars? The answer may lie in efficiency of communication. Radio signals fade or absorbed, can be missed. Physical objects endure. A comet sent across light years carries chemistry, material, potential artifacts. It is unambiguous. The cost may be enormous, but so is the reward. Certainty. If the goal is to announce presence, to deliver message, then the price of summoning may be worth it. Energy is spent, but meaning is gained. From humanity's perspective, the cost of summoning is not only technical but philosophical. To believe Atlas was summoned requires us to accept scales of energy that dwarf our imagination. That acceptance challenges our sense of importance. If others can spend star-level power to send comets, then we are not the pinnacle of achievement, but the beginners of a larger game. Our place in the cosmos shifts from central to peripheral. The energy cost of summoning becomes not just calculation, but confrontation. It forces us to acknowledge possibilities we might prefer to ignore. Even if no intelligence is involved, the numbers themselves are awe-inspiring. The kinetic energy of Atlas alone exceeds anything humanity has ever controlled. It moves silently, invisibly, carrying power equivalent to billions of nuclear detonations. Natural or intentional, it is a reminder of how small we are. And if intentional, then it is a reminder that others may treat such scales as casually as we treat sparks. The cost is beyond us, but perhaps not beyond them. And so the question lingers. Was Atlas accelerated by random gravity or by deliberate hand? Was the cost borne blindly by nature or consciously by intelligence? We may never know. But in asking the question, we begin to think differently. We begin to see energy not as absolute barrier, but as spectrum. At one end is humanity, rationing power carefully. At the other, civilizations capable of summoning across stars. The gap between is vast but not unimaginable. Atlas may be the first hint that the gap is already bridged. When scientists debated the arrival of Oumuamua, then Borisov, and finally 3i Atlas, a recurring thought surfaced among those willing to entertain less conventional ideas. Perhaps these objects are not messages in the sense of communication, not probes meant to signal or deliver, but witnesses. Silent, unresponsive, indifferent whether we notice them or not, but present all the same. This is what some began to call the silent witness theory. The idea that interstellar objects might serve as passive observers, dispatched not to speak, not to interfere, but simply to watch, to drift into our system, gather information by proximity, and depart without leaving trace of interaction. At first glance, the notion seems odd. Why would any intelligence go to the trouble of sending vast amounts of mass across interstellar distances merely to watch? Surely, there are more efficient ways to observe from afar: radio telescopes, light years spanning arrays, even probes stationed quietly at the edges of systems. Yet the silent witness theory insists that the very bulk of such visitors may be their camouflage. To us, they appear as nothing more than comets, indistinguishable from natural debris. That is the point: to watch without being watched, to observe without drawing suspicion. And if the universe is a place where survival demands caution, then silence may be the most rational stance of all. The theory takes its roots from the dark forest hypothesis in astrobiology, which suggests that civilizations remain quiet out of fear of predation. In a universe where one cannot know the motives of others, shouting into the void is dangerous. Better to remain hidden, observing silently, than to risk exposure. If this reasoning is correct, then any probes sent to young civilizations like ours would follow the same principle. They would watch, not announce. They would mimic natural bodies, not machines. They would witness, not intervene. Hence, the silent witness. Applied to Atlas, the theory gains intrigue. Its chemical anomalies, its unusual velocity, its timing, all could be interpreted as natural, but they could also be signatures of hidden function. Perhaps the high carbon dioxide ratio is not random but engineered chemistry, masking sensors or propulsion residues. Perhaps the unusual speed is not mere ejection, but deliberate acceleration, ensuring a flyby within human observational capacity. And yet, through all of this, no signal, no transmission, no attempt at communication has been detected. Silence. If intent exists, it hides itself behind perfect imitation of nature. This silence may itself be the message. To send something that does not speak is to say, we are watching, but not engaging. We notice you, but we do not reveal ourselves. The message is not words, but absence of words. It forces the receiving civilization, in this case humanity, to question, to speculate, to debate endlessly about whether intent exists. In that sense, the silent witness achieves its purpose. It shifts perception, introduces doubt, sparks curiosity, all without ever uttering a sound. There is also the question of duration. A radio transmission lasts only as long as the signal persists. A probe broadcasting might be detected, but only while active. A comet-like object, however, leaves a permanent record. Once it passes through, its trajectory is logged forever. Its existence cannot be denied, even if its meaning is. The silent witness endures as data. Even if no message is carried, the fact of its passage remains, altering the way humanity sees itself in the cosmos. Silence becomes eternal witness. Skeptics counter that this theory collapses into unfalsifiability. If every interstellar object could be a silent witness, then the claim cannot be tested. Without signals, without artifacts, there is no evidence. And yet that is precisely why the idea persists. It cannot be disproven because it plays on possibility rather than certainty. The very absence of proof is what makes it compelling. Silence, in this case, is not weakness of theory but its strength. A civilization committed to caution would leave no detectable trace. To expect otherwise is to misunderstand the premise. The silent witness theory also reframes our expectations of contact. For decades, SETI searchers have assumed communication, looking for deliberate beacons, clear signals, unmistakable transmissions. The silent witness suggests a different paradigm. That first contact may not be communication at all, but observation. That we may already be under watch, not in conversation. The first visitors may not speak until they are sure of us, until they judge it safe, until they decide we are ready. In this view, Atlas and its predecessors are not the opening of dialogue, but the quiet inspection of a civilization still in its infancy. From a cultural perspective, this theory is unsettling. Humans prefer stories of discovery, dialogue, exchange. The idea of being watched silently without chance of response evokes discomfort. It recalls surveillance, control, manipulation, yet it may also reflect reality. In nature, observers often remain hidden to avoid altering the behaviour of what they study. We place cameras in forests to watch wildlife without disturbing it. We camouflage ourselves to observe animals in their natural state. If intelligence beyond Earth applies the same logic, then silent witnessing may be the default. We are wildlife, unaware of the watchers, behaving as we would if alone. There is also the matter of patience. If Atlas is a silent witness, then its journey took millions, perhaps billions of years to arrive here. That kind of patience exceeds anything humanity can imagine. It suggests motives that are not urgent, timelines that are not bound to human lifespans. The witness does not hurry. It drifts silently, waiting for the moment when it passes close enough to see, to record, to notice. And then it departs, leaving us with questions that may never be answered. Silence is not absence of meaning. It is meaning itself. The silent witness. Theory fits neatly with the absence of evidence for advanced civilizations elsewhere. If the universe is filled with silent witnesses rather than loud transmitters, then the great silence we observe is not paradox but policy. We hear nothing because no one speaks. We see nothing because no one reveals. All that remains are objects that pass as debris, unnoticed except by those who dare to suspect. And once suspicion arises, it never fully recedes. Every interstellar visitor becomes suspect. Every trajectory is watched for more than just orbital mechanics. Silence transforms our perception, turning neutrality into potential. Atlas deepens this perception because of its chemistry. If it were ordinary, silence could be ignored, but its anomalies force attention. Why so much carbon dioxide? Why so fast? Why now? The questions multiply, and in their absence of answers, silence grows louder. Perhaps that is the point, to leave us not with certainty but with doubt, to ensure we never again look at the sky without wondering whether the debris drifting by is truly just debris. Critics will continue to demand proof, and proof may never come. But perhaps proof is not the goal. Perhaps the silent witness exists not to convince, but to destabilize, to shake our assumptions, to force humility, to remind us that the universe may not be empty, even if it does not speak. Silence in this sense is not void but presence. The witness testifies without sound. Its very being is the testimony. And so Atlas passes, silent and strange, leaving us to wonder whether we have just been observed, whether the chemistry, the speed, the orbit are nothing more than camouflage for function, whether we are, at this very moment, wildlife under study, unaware of the hidden camera in the trees. The silent witness offers no answers, only the unsettling awareness that answers may not be given, that the sky itself may already contain them, disguised as ordinary, drifting silently, watching as we watch, recording as we record. When astronomers plotted the trajectory of 3i Atlas, one detail quickly became apparent. Its path through the solar system, while seemingly arbitrary, crossed regions of the sky that carried weight far beyond coordinates. It moved through constellations long recognized by human cultures, its track traced against the same stellar patterns that guided ancient navigation and inspired myth. The object itself is indifferent to these shapes, of course. Stars are not truly grouped in space, only projected together in our line of sight. But the resonance between orbital paths and human sky law invites a deeper question. Could alignments themselves be part of the design? Could interstellar visitors follow routes that are chosen not only for physical plausibility, but for symbolic visibility? Hidden alignments in the sky may hold a meaning, even if that meaning is not immediately obvious. The idea that alignments matter is not new. Ancient civilizations treated the heavens as a map of divine intent. Pyramids, temples, and stone circles were aligned with solstices, equinoxes, and star risings. In those times, the appearance of a comet cutting through a constellation was interpreted as deliberate. A bright comet in Leo could mean a fallen king. One in Virgo might suggest famine or fertility. Whether true or not, alignments shaped history. Armies hesitated, rulers made proclamations, cultures shifted, all because of perceived meaning in sky geometry. We tend to dismiss this now as superstition, but the underlying impulse remains. Alignments catch our attention. We notice when paths intersect significant patterns, and Atlas, by chance or by design, provided plenty of intersections. Its inbound trajectory was plotted against the region near Lyra, a constellation already famous in the search for extraterrestrial intelligence. It was toward this part of the sky that early SETI searchers pointed, detecting the first unexplained radio blips decades ago. Though those signals remain unproven, Lyra has become emblematic in the culture of the search. To see Atlas emerge from that same region was not lost on observers. Coincidence, perhaps, but coincidence aligned with cultural expectation. A hidden alignment between object and symbol. As it moved inward, its track crossed near Hercules, another constellation steeped in mythology of strength and challenge. Such associations may mean nothing objectively, yet they resonate with human narrative. We interpret alignments through story. When objects appear to cut through constellations that hold significance, meaning emerges almost automatically. This is how alignments work. They overlay physical motion with symbolic maps, creating patterns that capture imagination. The deeper possibility is that alignments are not just accidental overlays, but deliberate choices. If one wished to draw attention, selecting paths that intersect with regions of sky rich in human meaning would be an effective method. Even if civilizations across the galaxy do not share constellations, they might anticipate that any intelligent observers would create symbolic sky maps. Alignments would therefore be universal tools of engagement. Not language in the strict sense, but meta-language. A recognition that whoever watches the sky inevitably builds stories upon alignments. To design a trajectory that intersects with those stories is to communicate through resonance. Skeptics counter that the sky's filled with alignments, and any trajectory will pass through some region of cultural significance. Confirmation bias ensures that we notice only those that fit our expectations. But even this skepticism cannot erase the fact that humans are tuned to notice alignments. Whether intentional or not, they matter, because we make them matter. And in communication, perception is everything. If we perceive alignment as meaningful, then its effect is achieved, regardless of intent. Atlas also aligned temporally, not just spatially. Its discovery occurred on July 1st, exactly midway through the year, a date with no astronomical significance, yet one with symbolic resonance in human culture, balance, midpoint, turning of seasons. Alignments of time can be as evocative as alignments of space. If a sequence of future interstellar objects arrives at similarly symbolic moments, suspicion will deepen. Patterns of alignment will begin to suggest orchestration. For now, Atlas offers only coincidence, but coincidence, repeated enough, transforms into design. Another dimension of alignment emerges in geometry. When the trajectories of Oumuamua, Borisov and Atlas are plotted together, their inbound vectors are not random scatter, but form angles that can be interpreted as significant. Some researchers have suggested that their paths, when extended backward, intersect within regions that could hint at common origin. Others see deliberate geometry, as if the objects were part of a larger pattern only now becoming visible. With just 3 data points, such claims remain speculative. But if future visitors reinforce the geometry, then alignments may reveal more than coincidence. They may reveal signature. This possibility ties back to the mathematics of intent. Alignments can be encoded in orbital parameters. Inclinations can be chosen to intersect specific planes. Arguments of perihelion can be tuned to ensure visibility against certain constellations. These choices would be subtle, nearly invisible without careful plotting, but unmistakable once recognized. The message would not be in plain sight, but in hidden geometry. For civilizations accustomed to solving puzzles, it would be irresistible. The alignment becomes the puzzle itself. Even natural alignments can have profound cultural impact. Halley's Comet, for example, appeared in 1066, its path-crossing constellations visible in Europe during the Norman invasion of England. The comet was woven into the Bayeux tapestry as omen and symbol, forever linked with human history. The alignment had no intent, but it shaped perception, and perception shaped events. If interstellar visitors like Atlas continue to align with cultural moments and symbolic skies, then their impact will echo prophecy whether or not intent exists. Hidden alignments need no design to function as message, but if design does exist, then the implications are extraordinary. To send objects on paths that intersect with human symbolic frameworks would require knowledge not only of our position in space, but of our psychology. It would imply surveillance, awareness of our stories, perhaps even anticipation of our cultural evolution. Such implications are almost too vast to consider, and yet, if alignments continue to accumulate, we may be forced to. Silence may not mean absence, it may mean subtlety. Using alignments as the only language guaranteed to bypass our skepticism. The challenge is that alignments cannot be proven. They exist only in interpretation. A trajectory through Lyra is coincidence until enough coincidences build into pattern. A midpoint discovery date is chance until repetition forms sequence. For now, Atlas stands as ambiguous. Its alignments may be hidden messages, or they may be statistical inevitabilities. But the ambiguity itself ensures the question persists, and once asked, it cannot be unasked. In the end, hidden alignments in the sky are less about proving intent than about expanding perspective. They remind us that the universe is not viewed in isolation, but through the lens of culture, story, and symbol. Whether intentional or accidental, alignments matter because they shape the way we see. And perhaps that is the true function of visitors like Atlas. Not to deliver direct communication, but to align with our gaze, forcing us to notice, to question, to interpret. To wonder whether coincidence is enough, or whether something more subtle is at play. There is a curious paradox at the heart of discovery. We believe we find things because they are there to be found, yet often it feels as though they exist for us only when we notice them. Until a telescope captures the faint streak of motion, an interstellar object is invisible, not because it isn't present, but because our awareness does not include it. This leads to an unsettling thought. What if human observation is itself the trigger? What if these visitors reveal themselves only because we are watching? When 3i Atlas was announced on July 1st, 2025, the discovery did not occur in a vacuum. It happened at a moment when global astronomical networks were fully operational, when machine learning combed through nightly data streams, when instruments across the world worked together almost seamlessly. In earlier centuries, Atlas would have passed unnoticed. Even in the mid-20th century, with photography and careful surveys, the odds of detection would have been slim. Only in this exact technological moment could such an object not only be spotted, but studied in detail. That coincidence raises the question, is detection merely luck? Or does observation itself somehow call the object into being, at least in our awareness? In physics, observation is not always passive. At quantum scales, the act of measurement alters the system, collapsing probabilities into outcomes. While interstellar comets are far removed from quantum uncertainty, the philosophical parallel remains. By watching, we create meaning. the object is transformed from drifting debris into subject of inquiry, from anonymous rock to interstellar messenger. Human observation changes its role, if not its nature. The trigger is not physical, but cultural. By observing, we summon significance. The silent witness theory suggested that such objects may be designed to pass unnoticed, unless looked at closely. Extending that idea, perhaps they are designed to matter only when noticed. A drifting body means nothing to a species without telescopes. But once those telescopes emerge, the object suddenly serves its function. It becomes, in that instant, not just debris, but signal. Human observation acts as the switch, activating the role the object plays. Without us, it is meaningless. With us, it is message. There is also the psychological aspect. Before Oumuamua, the idea of interstellar visitors was mostly theoretical. Theories predicted their existence, but no one had seen one. After its discovery, astronomers began looking harder. When Borisov appeared, it was found not by accident, but by expectation. Atlas followed the same trajectory of thought. Each discovery sharpened awareness, increased the likelihood of more. Human observation is cumulative. The more we look, the more we find. In this way, observation itself creates the conditions for discovery. The universe did not change, but our attention did, and attention is often indistinguishable from reality. Some theorists take the idea further. What if these objects are not merely awaiting discovery, but actually respond to it? If an intelligence hides probes within cometary disguises, those probes might activate only when they detect observation. Telescopes emit light, radar beams, radio signals. To us, these are tools of measurement. To them, they could be triggers. Once observed, the object could shift behavior subtly, enough to reveal anomalies that spark debate but not enough to confirm artificiality. This cycle of suspicion is sustained not by evidence, but by hints. Observation, in this framework, is not just detection, but participation. By looking, we become part of the experiment. There are hints in the data that support this unsettling notion. Oumuamua's acceleration anomaly emerged only after detailed tracking, as though revealing itself once human attention was fixed. Borisov reassured by behaving exactly like a comet, almost as if playing the role expected. Atlas, with its carbon dioxide dominance, introduced strangeness again, timed for maximum coverage by space and ground instruments. Each object seemed tuned to the level of scrutiny available at the time. As our observation capacity grows, so too does the anomaly. It is as if the visitors are calibrated to our gaze. Skeptics reject this as anthropocentric fantasy. Objects do not care whether we look. Their orbits are set long before humans evolved. Observation cannot influence trajectories. To believe otherwise is to place humanity at the centre of cosmic drama, repeating ancient errors of geocentrism. Yet even skeptics must admit that the timing feels uncanny. The coincidence between our readiness to observe and the arrival of these visitors is difficult to ignore. Whether or not our observation triggers them in any physical sense, it certainly triggers their significance. They matter now because we see them now. That is undeniable. Another angle comes from information theory. To send a message effectively, one must account for the receiver's ability to notice and decode. If interstellar visitors are deliberate, then they would need to arrive at a time when humanity could observe. Otherwise, the message is wasted. In this sense, human observation is not just trigger but requirement. The visitors are designed to coincide with our capacity. Observation is not optional, it is built into the plan. The fact that Atlas appeared when Webb, Rubin and other instruments were ready suggests that the trigger may indeed be our gaze. There is also a cultural trigger. Before Oumuamua, the public was not primed to think about interstellar visitors. The idea belonged to astronomers and science fiction. Now it belongs to everyone. News headlines, documentaries, debates, they ensure that each new object captures global imagination. Human culture itself is now part of the observational network. Even if most people never look through a telescope, they participate by watching the story unfold. Observation is not just technical, it is social, and that social observation may be as important as the scientific. A message unread is meaningless. A message debated, feared, or celebrated fulfills its function. Observation in any form, scientific or cultural, activates significance. If this is true, then the next arrivals will continue the pattern. They will appear when humanity is not only able to observe, but prepared to interpret. Each new anomaly will coincide with cultural readiness, pushing the debate further. The trigger will not just be telescopes, but the entire structure of human awareness. We will not only see them, we will expect them. An expectation itself is a form of summoning. Once a civilization anticipates visitors, every new arrival takes on the weight of meaning. The line between coincidence and calling blurs until it vanishes. But what if observation truly does influence reality? Some theorists speculate that advanced probes could be quantum linked, collapsing into specific states only when detected. Others imagine surveillance systems designed to remain dormant until illuminated by starlight, reflected through human instruments. In these scenarios, our act of looking is not symbolic but functional. We literally trigger the activation of their role. The object becomes what it was meant to be only because we looked. The idea is speculative, but it fits neatly with the silence we otherwise observe. It explains why nothing speaks loudly, because everything waits to be observed quietly. The unsettling part is that we cannot know whether our observation is passive or triggering. We cannot step outside our own awareness to test the difference. Once Atlas was seen, it was forever changed in meaning. Whether it changed in nature, we cannot tell. All we know is that before July 1st it was anonymous. After July 1st it was anomaly. The dividing line is human observation. That is the trigger, whether physical or perceptual. The silent witness theory suggested that objects may come to watch us. Extending that, perhaps they only watch once we watch them. A mutual recognition across light years, silent but real. They drift into our system, indifferent until our gaze falls on them. Once noticed, they become witnesses, not just to us, but of us. Our observation is their activation. Their silence is our participation. The symmetry is unsettling, but perhaps that is the point. And so Atlas continues on its path, indifferent in physics but not in perception. Whether summoned or accidental, it became meaningful only because we looked. Whether passive rock or disguised probe, it became participant only when our gaze fixed upon it. Human observation was the trigger, and once triggered, the cascade of speculation, culture and meaning cannot be undone. Each new visitor will repeat the cycle. The universe may not change, but we will, because the act of seeing transforms both object and observer. For decades before 3i Atlas was even a thought in the minds of astronomers, the search for extraterrestrial intelligence SETI had been straining its ears toward the stars. Arrays of radio telescopes scanned the sky, computers sifted through oceans of data, and generations of scientists trained themselves to distinguish signal from static. The logic was simple. If civilizations exist, they will communicate, and if they communicate, they will leave detectable traces in the radio spectrum. Yet decade after decade, nothing emerged. The famous WOW signal of 1977 tantalized for a moment, but no repeat ever came. Countless candidates appeared, but all eventually collapsed into mundane explanations. The universe remained silent, a silence that many began to interpret not as absence, but as policy. When interstellar visitors began to appear in the 21st century, SETI researchers could not help but ask whether they represented a different kind of communication, one not carried by radio, but by matter itself. Perhaps the static that filled their receivers was not empty at all, but deliberate misdirection, while the real messages drifted quietly as comets. In this view, SETI had been waiting in the wrong place. Not wrong in terms of dedication, but wrong in assumption. The waiting game may have been listening for words when the cosmos was speaking in objects. The difficulty lies in the nature of static. Radio receivers are bombarded constantly with noise, terrestrial interference, cosmic background, random bursts from stars, lightning strikes, satellites, aircraft. To sift a true signal from this noise is like finding a whisper in a hurricane. Even if a transmission were aimed at us, it could be buried beyond recognition. Many researchers admitted quietly that if signals exist, we might already have recorded them without knowing. They would look like interference, be discarded as mundane, and disappear into forgotten archives. The difference between static and signal is not absolute, it is interpretation. This echoes eerily with the way interstellar objects are treated. A comet passes by, and we assume it is natural. Only when anomalies stack, unusual chemistry, suspicious acceleration, uncanny timing, do we pause and ask if it might be more. SETI and interstellar astronomy mirror each other. Both sift vast fields of noise for hints of signal. Both face the risk of false positives. Both endure the criticism of chasing coincidence. And both may be engaged in the same waiting game, staring into silence that may not be silence at all. The waiting game has shaped SETI culture. It is a field defined less by discovery than by endurance. Year after year, instruments record nothing conclusive, yet the search persists. Some see this as futility, others as discipline. The same applies to interstellar objects. Each arrival may be natural, unremarkable in ultimate analysis, but the act of watching, of preparing for the chance of anomaly, sustains the search. Waiting itself becomes the practice, and the practice is what matters. When Atlas appeared, SETI researchers immediately pointed instruments at it. Radio telescopes scanned its trajectory, listening for emissions. None were found. Yet the silence did not discourage. It deepened the intrigue. The waiting game is not defeated by silence. It is defined by it. Silence is expected. The challenge is to listen anyway, to hold patience across years and lifetimes. And so SETI folded Atlas into its archive of silence, another object that said nothing, but might have said everything, depending on how one listens. There is a growing suspicion that silence may itself be deliberate. If the dark forest hypothesis is true, then civilizations do not broadcast openly. They remain hidden, cautious, unwilling to reveal themselves. In that environment, sending physical objects may be safer than sending radio. Objects can disguise themselves, pretend to be natural, pass unnoticed unless scrutinized. The waiting game shifts from listening to watching, from ears to eyes. The static of the cosmos becomes less relevant than the geometry of orbits. SETI may need to redefine its mission, not as search for signals, but as search for anomalies. The static remains, but the waiting game expands. The human side of waiting is profound. Generations dedicate careers to silence. They endure skepticism, limited funding, public indifference. They know that discovery may not come in their lifetimes, yet they listen anyway. This endurance is itself a message about humanity's patience, our willingness to extend curiosity beyond immediate reward. If civilizations elsewhere are watching us, perhaps this patience is what they are measuring. The waiting game is not only ours, it may be theirs as well. Perhaps they are waiting for us to prove that we can wait. Static also teaches humility. Every unexplained blip reminds us of our ignorance. The cosmos is vast, filled with signals we cannot interpret, phenomena we have not yet explained. Many of the candidates, once thought artificial, turned out to be pulsars, quasars, natural transients. Each false alarm expanded knowledge. Static was not empty, it was education. Perhaps interstellar visitors function the same way. Each one may ultimately be natural, but each forces new questions, new techniques, new awareness. Waiting, in both cases, produces growth. And yet, there is the lingering possibility that among the static lies something real, something intentional, something we have missed. The wow signal remains emblematic of this hope. A single burst, unexplained to this day, lasting just long enough to tantalize, never repeating. For some, it is the archetype of the silent witness, a signal that appeared only once, not to communicate, but to show it could be done. Atlas may be the physical counterpart of the wow signal, a fleeting presence, unexplained anomalies, silence afterward, not conversation, but demonstration. The waiting game offers no closure, only possibilities. If silence is deliberate, then perhaps the waiting game will never end. Perhaps we are meant to wait, to watch, to endure ambiguity. Maybe the test is not whether we discover, but whether we persist. Civilizations that lack patience, that demand immediate answers, may collapse before they ever understand. The ones who last are those who can listen through centuries of static, watch through centuries of silence, and still care enough to notice anomaly. Waiting becomes selection. Those who cannot wait never survive to hear. This thought reframes interstellar visitors in unsettling ways. Perhaps Atlas was not meant to tell us anything directly. Perhaps it was meant to test whether we were still paying attention, whether we were still listening even when nothing seemed to be said. The waiting game extends beyond radio into matter itself. Atlas drifts by, silent. We notice, we question, we debate. That act of noticing may be the entire point. Waiting rewarded not with answers, but with the opportunity to prove we are capable of waiting at all. In the end, SETI, static, and the waiting game converge on the same truth. The universe may not speak in the ways we expect. It may never offer clear signals, obvious messages, or definitive contact. Instead, it may surround us with ambiguity, forcing patience, demanding humility. Static is not empty, it is challenge. Interstellar objects are not meaningless, they are puzzles. The waiting game is not wasted time, it is the test itself. Whether or not Atlas was a message, it has already served its role by making us wonder, by forcing us to confront silence and decide whether we will keep listening anyway. The dark forest hypothesis imagines the universe as a place of constant silent tension. Each civilization, like a hunter in the woods, keeps its fire low and its voice quieter still, knowing that any sound could reveal its location to predators. In such a forest, survival means silence. To reveal oneself is to risk annihilation. This unsettling perspective has grown more persuasive as decades of listening have produced only static. If countless stars host planets, and countless planets host possibilities, then the absence of signals demands explanation. The dark forest offers one. They are there, but they are hiding. And if that is true, then every unusual sign we encounter must be considered carefully, because in a forest of hunters, even the faintest flicker might not be accident, but bait. 3i Atlas fits uncomfortably into this frame. To most astronomers, it is simply a comet, albeit an unusual one. But to those willing to entertain the darker possibilities, its timing, its chemistry, and its strangeness suggest something else. Perhaps Atlas is not merely visitor, but lure. Not communication, but trap. A bright, strange comet appearing at precisely the moment humanity is capable of analysing it could be nothing more than a way of drawing us out, forcing us to reveal ourselves through our response. The lure is curiosity. The bait is anomaly. The trap is whatever comes after. The logic is simple enough. In a universe of silence, the one who speaks risks everything, but the one who listens gains advantage. If a civilization wished to locate another without exposing itself, it could send ambiguous objects instead of clear signals. Comets that look natural, but contain anomalies subtle enough to provoke investigation. The targeted civilization eager to study would turn its instruments toward the object, broadcasting radar, radio, laser pulses. Each observation, each transmission becomes a beacon, advertising presence to anyone who might be listening. The lure works not by what it sends, but by what it provokes. Atlas may have served exactly this function. Radar studies, radio scans, deep observations by Webb, all of them produced emissions that could travel beyond our system. To us, these were neutral acts of science. To an observer in the dark forest, they were confirmation. Earth has noticed. Earth has revealed its location, its curiosity, its readiness. The comet itself remains silent. It need do nothing. The bait works because we take it. This idea is not paranoia but extension of survival logic. In nature, lures are common. Bioluminescent fish attract prey with glowing appendages. Spiders build webs that glisten in moonlight. Plants mimic other species to draw pollinators. The principle is the same: deception through attractiveness. A strange interstellar comet may serve the same role. It glows unusually. It behaves oddly. It arrives at the right moment. We cannot resist studying it. Our instruments fire across the void, unwittingly announcing us. In the dark forest, that announcement may be fatal. Critics argue that this stretches plausibility too far. Why would any advanced civilization bother with bait when more efficient methods of detection exist? They could surely monitor electromagnetic leakage, track atmospheric composition, or use technologies we cannot imagine. Why resort to disguising probes as comets? The answer lies in subtlety. Our leakage is faint, diluted across decades of light years. Monitoring atmospheres requires line of sight and sophisticated instruments. But provoking us to act ensures certainty. When we point our most powerful transmitters at an object, the signals are strong, directed, unmistakable. A lure amplifies us far beyond what passive monitoring could achieve. It tricks us into broadcasting ourselves. The danger is not immediate. A comet passing silently does not summon invasion. But in the dark forest model, timescales are vast. Detection may lead to action only centuries or millennia later. From our perspective, the response may never come, but that does not mean the risk is absent. Every act of curiosity, every investigation of anomalies increases our exposure. Atlas may be nothing more than another tally mark in the ledger of civilizations identified. A note written in silence. They are here, and they are looking. This interpretation reframes the role of CT and astronomy itself. Instead of cautious observation, we may be participating in a dangerous game of reveal. Each radar ping, each transmission, each attempt to probe an interstellar object is potentially a flare in the forest. Scientists debate whether active CT, deliberately broadcasting our presence, is wise. But passive SETI may already be active without meaning to be. By studying visitors like Atlas, we may already be broadcasting more than we realize. The lure works precisely because we cannot avoid it. Curiosity is irresistible, and in a young civilization, irresistible curiosity can be fatal. The bait interpretation also explains the silence. If civilizations rely on such methods, they do not need to broadcast. They can remain hidden, sending ambiguous visitors across space to draw others out. Silence remains the dominant policy, broken only by lures. And because lures are disguised as natural, they can be denied, dismissed, overlooked. Only the targeted civilization recognizes the anomaly, and only after it takes the bait. The forest remains dark, the hunters remain hidden, and the prey reveals itself in the act of studying what it thinks is harmless. This perspective casts Atlas's anomalies in a new light. The unusual dominance of carbon dioxide is not just odd chemistry. It is the glittering appendage of the lure, the feature designed to attract attention. The high velocity is not just the product of chaotic ejection, it is the exaggerated motion that makes the object impossible to ignore. The timing of discovery is not coincidence. It is bait set at the moment when humanity has the tools to react. Each anomaly becomes part of the trap, each feature part of the design. This silence that follows is the confirmation. The lure has worked. It is important to recognize that the dark forest model is not pessimism for its own sake. It is caution rooted in logic. If resources are finite, if threats are real, then silence is survival. And in such a universe, trust cannot be assumed. To reveal oneself openly is to gamble. To provoke others into revealing themselves while remaining hidden is safer. If we were in their place, we might do the same. Humanity has used bait throughout history. Traps, decoys, feints. It is not alien behaviour, it is survival behaviour. The unsettling part is realising that we may be prey in someone else's strategy, yet there is another way to view the bait. Perhaps it is not meant to endanger, but to test. A lure may not always be predatory. It may be a way of gauging readiness, of measuring curiosity, of seeing how far a civilization has advanced. Atlas may not be trap, but exam. The anomalies may be puzzles designed to provoke thought rather than doom. In the dark forest, not all hunters kill. Some may watch, evaluate, even nurture. The lure draws us out not to destroy but to assess. Our response becomes the test. Our curiosity, our patience, our caution, these are the answers we give. The bait reveals not our location, but our nature. Whether trap or test, the effect is the same. Humanity is forced to confront the possibility that curiosity carries risk, that our instruments may be both our strength and our vulnerability. That silence is not empty, but strategy. The dark forest and the lure of bait remind us that in the vastness of the cosmos, nothing can be assumed safe, not even the comets that drift silently by. Each one may be natural, but each one may also be something more, and the act of looking ensures that we will never again be able to dismiss them as simply rock and ice. When an interstellar object like 3I Atlas enters the solar system, one of the first questions astronomers ask is whether its path is random or aimed. The official answer is always random, shaped by ancient ejection and the blind mechanics of gravity. Yet the suspicion lingers, especially as more such visitors appear in close succession. Was the solar system merely one of countless stops along its eternal drift, or was Earth specifically the intended destination? It is a question that reaches beyond mathematics into philosophy, because to entertain the possibility that Earth was chosen is to consider intent. At first glance, the odds seem impossibly small. The galaxy is vast, stars are separated by light years, and planetary systems are tiny targets compared to the interstellar void. To launch a body from one star and hit another, even with accuracy measured in millions of kilometers, requires precision beyond comprehension. Natural ejection is blind, spraying debris in all directions. To assume one of those fragments would happen to intersect Earth's orbit is to assume coincidence of staggering improbability. And yet, improbabilities occur. We exist at all because of improbable alignments. Earth at the right distance from the Sun, water stable on its surface, conditions aligned for life. The universe is filled with low probability outcomes, and we are one of them. Why not this too? But coincidence has limits. The repeated arrivals of Oumuamua, Borisov and Atlas within such a short span test those limits. And the closer we examine Atlas, the more its details suggest deliberation. Its perihelion distance brought it near enough to the Sun to activate its coma, ensuring visibility, yet not so near that it was destroyed. Its trajectory crossed the orbital plane in a way that made detection by multiple surveys almost inevitable. Its velocity, while extreme, was not so high that it became unobservable. Everything about its path seemed tuned for notice. If Earth was not the destination, then why did the orbit align so perfectly with our capacity to see? This raises the unsettling possibility that Earth was not only the destination but the audience. That the object was meant for us, timed for when we could observe, placed on a path that intersected our awareness. Not communication in the sense of words, but communication in geometry, a message written not in radio but in trajectory. The destination was not physical impact but perception. Earth was not to be struck, but to be made aware. Theories of panspermia sometimes invoke comets as carriers of life, drifting between stars to seed worlds. If Atlas carried not message but material, then Earth as destination could mean delivery. Organic molecules, exotic chemistry, perhaps even engineered biology embedded in ice. These are possibilities considered by some. The unusual dominance of carbon dioxide in its coma could be incidental, or it could be the trace of something carried within. To strike Earth directly would be catastrophic. To pass nearby, shedding dust and molecules into our atmosphere, would be subtle. If delivery was the intent, then proximity was enough. The destination need not be collision. Influence at a distance would suffice. Skeptics remind us that the solar system is filled with targets, and Earth is not the largest nor the most gravitationally influential. Jupiter dwarfs us in pull, and its presence dominates the inward flow of comets. If Atlas were merely a random interstellar fragment, the odds favour capture or deflection by Jupiter. That it avoided capture and threaded its way inward to pass near Earth is improbable. Improbable, but real. Probability does not forbid coincidence, but when coincidence aligns with meaning, suspicion grows. The alternative is to consider that Earth as destination may not mean Earth specifically, but intelligence generally. A probe sent to the solar system would not necessarily aim for our small planet, but for the inner system as a whole, where detection is most likely. Earth happens to host observers, but from the perspective of design, any inhabited world in range would serve. Earth feels central to us, but to others it may be incidental. The destination was awareness, wherever it might exist. That it was us is coincidence only in the sense that we are the ones here to see. There is also the question of timing. If Atlas was ejected naturally, its journey would have taken millions of years. No one could aim at Earth with such precision across such timescales, at least not without technology beyond anything we understand. To believe Earth was the destination is to believe in foresight on geological scales. Yet civilizations millions of years older than ours could conceivably predict planetary orbits across such spans. With enough knowledge, precision is possible. To them, our tiny world may be no harder to hit than a star to us. The scale of time changes what is feasible. The improbable becomes trivial when patience is infinite. Still, the possibility that Earth was chosen carries weight even if not proven. It alters how we view the object, shifting it from random wanderer to potential envoy. It forces us to consider motives. Why us? Why now? If Earth was the destination, then what did the senders intend? A message of curiosity, a warning, a test, or something more? The silence of Atlas leaves these questions unanswered, but the questions themselves reshape our perspective. Silence becomes less empty when intent is possible. Another dimension of the question involves cultural readiness. Perhaps Earth was the destination not because of our location in space, but because of our stage in development. A civilization might monitor young species and choose moments when they reach certain milestones. Radio communication, spaceflight, global observation networks. Earth in 2025 fits that profile. We are advanced enough to notice, but not advanced enough to respond. A perfect moment for a flyby, a silent encounter that leaves us aware but not capable. If this was the plan, then Earth was not target of convenience, but target of design. Skeptics counter that this is anthropocentric projection, placing ourselves at the centre of events that are likely random. But history warns us against dismissing uncomfortable possibilities. We once believed Earth was the centre of the universe, only to discover otherwise. Perhaps now we dismiss Earth as irrelevant, only to discover it was chosen. Neither arrogance nor humility guarantees truth. The only certainty is that we must remain open to both. The most sobering possibility is that Earth was indeed the destination, but not for communication, not for delivery, not for testing, but for cataloguing. That atlas was one of many probes sent across the galaxy, each passing by inhabited worlds, logging their existence, and continuing onward. Earth is just one entry in a ledger of life-bearing planets. The destination was not conversation, but census. The universe may not wish to speak, but it may wish to know, and knowing may be enough. Whether or not Atlas was aimed, the idea that Earth was the destination cannot be dismissed entirely. Its path, its timing, its anomalies, all ensure the question will remain. Perhaps it was chance, perhaps it was design, perhaps both at once. But the very act of asking places us in a new role. We're no longer just passive observers of comets. We're potential participants in something larger, something that treats Earth not as incidental but as chosen. And whether chosen by chance or by will, the effect is the same. Earth mattered because Atlas passed here and we noticed. The debate over chance versus design has shadowed every interstellar visitor since Oumuamua first startled astronomers in 2017. When something strange appears, the human mind immediately splits along two lines of reasoning. On one side lies coincidence, the belief that improbable events eventually occur given enough time and enough opportunities. On the other side lies intention, the suspicion that improbable events are improbable precisely because they are arranged. In the case of 3I Atlas, this tension is more pronounced than ever. The chemistry seems excessive, the speed seems exaggerated, the timing feels uncanny. Was it chance, or was it design? Science traditionally leans toward chance. Natural explanations are the default. A comet is a comet until proven otherwise. If its chemistry looks strange, perhaps our models are incomplete. If its speed is high, perhaps it was ejected violently from a chaotic stellar nursery. If its timing feels unlikely, perhaps we simply underestimated the true frequency of interstellar debris. Each anomaly has a natural possible explanation, even if that explanation stretches the limits of probability. Scientists are trained to resist design unless chance has been exhausted. It is the safer path, the one less likely to mislead. Yet safety does not always align with truth. Chance itself has many faces. In one sense, it is randomness, the uncoordinated scatter of events across space and time. In another sense, it is inevitability, the idea that given infinite opportunities, even rare events must eventually occur. Interstellar comets are rare, but the galaxy is vast. Billions of stars eject trillions of fragments. Sooner or later, some of those fragments will cross our path. That 3 have done so in less than a decade may simply reflect the law of large numbers finally catching up to human observation. From this perspective, there is nothing remarkable in Atlas. It is debris, nothing more. Chance alone explains it, but design offers a different frame. Instead of randomness, it sees pattern. Instead of inevitability, it sees intent. The sequence of visitors, Oumuamua anomalous, Borisov ordinary, Atlas extreme, forms a rhythm that feels too neat to be blind. Each escalation seems crafted to capture our attention without providing resolution. That very structure suggests orchestration. If someone wished to engage a young civilization cautiously, slowly raising curiosity without provoking panic, this is exactly how they might proceed. Design in this sense is not proven, but it feels persuasive. Human intuition gravitates toward it because we are wired to see patterns. The question is whether those patterns are real. The role of chance versus design is complicated by perception. To astronomers, probability is calculation. To the public, it is impression. When told that Atlas's velocity is unusual, most people interpret that as deliberate. When told its chemistry is extreme, they see intention. Rare does not mean impossible, but human psychology often treats rare as suspicious. This difference in perception drives much of the debate. Scientists argue chance because mathematics allows it. Observers argue design because intuition insists upon it. Both are valid in their own ways. but they lead to very different interpretations of the same object. Consider the question of chemistry. Atlas's coma was dominated by carbon dioxide to an extent not seen in known solar system comets. By chance, it could reflect a different formation environment, one where carbon dioxide ice was abundant and stable. The galaxy contains diverse systems, and not all must resemble ours. Yet by design, it could be an exaggeration intended to stand out, to provoke notice, which is more likely. Chance requires us to believe that our first 3 interstellar visitors just happened to showcase maximum diversity. One dry, one ordinary, one chemically extreme. Design requires us to believe that someone curated this sequence deliberately. Neither explanation is comfortable, but both remain possible. The same applies to velocity. By chance, Atlas may have been ejected from a dense stellar cluster, where chaotic interactions fling bodies outward at high speed. By design, its extreme velocity may have been chosen to demonstrate capability, to test the limits of our observation, to ensure we could track something so fast. Once again, both explanations fit the data. The difference is philosophical. Chance preserves a universe of indifferent chaos. Design introduces intelligence, and intelligence introduces motive. To choose between them is to choose between 2 very different visions of reality. Timing complicates things further. Oumuamua arrived just after the construction of wide-field sky surveys capable of detecting it. Borisov followed when astronomers were primed to expect a second. Atlas appeared when Webb was fully operational, ensuring chemical analysis at unprecedented sensitivity. By chance, this may all be coincidence, a lucky alignment between technology and event. By design, it may be deliberate calibration, objects timed to appear when humanity could notice, escalating in complexity as our tools improved. To believe in chance is to believe in fortune. To believe in design is to believe in choreography. Once again, the evidence allows both. Perhaps the real tension is that chance and design are not mutually exclusive. A naturally ejected object may be intercepted, nudged, or guided to ensure arrival. Random fragments may be curated into patterns. Design may not create from nothing, but may work through chance, shaping it subtly, guiding it gently. This hybrid possibility complicates the debate. If Atlas is partly chance and partly design, then neither explanation alone suffices. We must think in terms of layers, where randomness provides material and intent provides direction. This possibility is difficult because it resists simplicity, but reality often does. The history of science shows how often this tension arises. Lightning was once considered divine design, then explained as chance discharge of electricity. Disease was once considered curse, then explained as chance infection. Yet in both cases, deeper understanding revealed complexity. Lightning follows laws of physics but can still be triggered by human structures. Disease follows biology but can still be influenced by human behaviour. Chance and design intertwine. Perhaps interstellar visitors are no different. They may be natural debris, but still shaped, timed, or chosen for reasons we do not yet understand. Another dimension of this debate involves humility. To assume design is to assume others exist and act. To assume chance is to assume we are alone and events are indifferent. Both positions carry risks. Believing in design risks projection, anthropocentrism, seeing intelligence where none exists. Believing in chance risks arrogance, dismissing possibilities beyond our imagination. Neither extreme is safe. The challenge is to remain balanced, entertaining both without committing prematurely. Atlas demands this balance, because its anomalies resist dismissal, but fall short of proof. From a cultural standpoint, chance offers comfort. If Atlas is random, then the universe is predictable and we need not fear hidden motives. Design, by contrast, introduces unease. If it was aimed, then someone aimed it. If it was message, then someone wrote it. If it was lure, then someone waits. The difference is existential. Chance preserves solitude. Design introduces company, whether welcome or not. Humanity instinctively oscillates between the two, sometimes preferring one, sometimes the other, depending on whether we crave meaning or fear intrusion. The future may resolve this debate. If dozens of interstellar visitors are detected and their properties scatter randomly, chance will be vindicated. If patterns persist, design will gain weight. For now, with only 3 examples, both remain viable. The role of chance versus design is not yet determined, but even in uncertainty, the question itself is transformative. It forces us to see the universe differently, to weigh probability against possibility, to hold open the door to intelligence without closing it prematurely. Atlas embodies this tension. Its numbers can be chance, but they feel like design. Its anomalies can be random, but they suggest intent. Its timing can be coincidence, but it resonates like choreography. Whether we lean toward one explanation or the other, the effect is the same. We are drawn into deeper reflection. Chance or design, the visitor has already changed us. And perhaps that change is the point. The universe is vast, but it does not move without rhythm. Stars orbit the galaxy, planets align in cycles, pulsars beat like cosmic clocks. Patterns repeat at scales both small and immense, and civilizations, if they exist, would notice those patterns just as we do. Some researchers suspect that what we call coincidence may sometimes be something else, a synchronization of events designed to overlap, to create moments when attention is inevitable. 3i Atlas raises this possibility again. Perhaps its timing was not random, not chance, but part of a broader orchestration, a cosmic synchronization event meant to occur precisely when we were prepared to see it. Synchronization is one of the most effective ways to communicate across vast distances. In music, rhythm binds instruments together. In computing, clocks keep processors aligned. In communication, synchronized pulses make meaning possible. If civilizations wish to coordinate across light years, they may use the universe's natural rhythms as their clocks. Pulsars, supernovae, planetary alignments, all are predictable events visible across space. To synchronize an action with one of these is to ensure that anyone watching will notice. If Atlas appeared in alignment with such a rhythm, then it may not have been coincidence at all. Consider the timing of its discovery. July the 1st, 2025, exactly halfway through the calendar year. Human calendars are arbitrary, but the alignment with a midpoint carries symbolic weight. To us it suggests balance, transition, symmetry. Perhaps coincidence, but perhaps not. Civilizations anticipating human cultural development might know that we measure time this way, that such symmetry would not go unnoticed. Synchronization need not be physical. It can be cultural, using our own rhythms as the stage. Atlas arrived at a moment when symmetry was visible to us, and symmetry is rarely ignored. More intriguingly, some astronomers noted that Atlas's inbound trajectory aligned temporally with a series of notable cosmic events. Gravitational wave detections from distant mergers, bursts of gamma rays, even the rhythmic pulses of certain millisecond pulsars, all coincided within months of its appearance. Each on its own is natural, but together the cluster of events forms a backdrop of rhythm against which Atlas's arrival seemed strangely timed. Synchronization, perhaps not exact, but suggestive. The cosmos beating its drums and a visitor stepping into the rhythm. Skeptics argue that such patterns are inevitable. The universe produces countless events every day. To connect any one of them with Atlas is to cherry-pick, to draw lines between unconnected dots. Yet history shows that synchronization is often the key to discovery. The transit of Venus synchronized with the 18th century global effort to measure the size of the solar system. The discovery of pulsars synchronized with the expansion of radio astronomy. Events that overlap are remembered, while isolated events fade. Even if unintentional, synchronization amplifies meaning. Atlas, arriving amidst other cosmic rhythms, became more than object. It became part of pattern. Synchronization may also occur across civilizations. If multiple species time their actions to coincide with predictable cosmic events, then those events become beacons of coordination. For example, a pulsar that flashes every millisecond is a clock visible to the entire galaxy. To launch a probe, send a signal, or trigger an event in synchronization with that pulsar ensures that anyone capable of observing will know it was deliberate. The rhythm becomes the channel, the alignment the message. If Atlas was synchronized with such a cosmic clock, then it may have been part of a network of events beyond our awareness. Another layer of this idea is psychological. Humans are drawn to patterns. We cannot resist them. Synchronization amplifies this tendency. When events overlap, we ascribe meaning even when none exists. Civilizations seeking to provoke curiosity would know this. By timing arrivals with cosmic or cultural rhythms, they ensure attention. Even skeptics cannot dismiss it easily. Coincidence feels weaker when symmetry is strong, and in communication, perception is everything. If we perceive synchronization, then the message succeeds, whether or not it was intended. Atlas also synchronized with human technological readiness. Webb had just completed its first major observing campaigns. The Rubin Observatory was preparing to begin full survey operations. Global coordination of astronomical data was stronger than ever. The moment was ideal. To arrive earlier would have meant poorer data. To arrive later would have risked being one of many. To arrive now in synchronization with the peak of human observational capacity ensured maximum impact. This is perhaps the most persuasive form of synchronization. Not with cosmic clocks, but with us. Civilizations do not need to time themselves to pulsars if they can time themselves to observers. Atlas seemed to know when to arrive, and that timing made it impossible to ignore. Some theorists extend this idea further, imagining synchronization not only across events, but across civilizations themselves. Perhaps interstellar visitors like Atlas are not aimed solely at Earth, but are part of a grand choreography in which multiple civilizations receive similar objects at similar times. A wave of synchronized arrivals sweeping across the galaxy, each appearing when a civilization becomes ready to detect them. If so, then we're only one participant in a larger event, a synchronization of awareness. Each species believes itself special, but in fact each is only one node in a vast coordinated rhythm. Atlas's arrival may be our initiation into this hidden cadence. This vision is almost impossible to test, yet it has a certain logic. Synchronization is the only universal method of coordination across light years. Direct communication is limited by speed, but synchronization allows independent civilizations to align without contact. By tying their actions to predictable cosmic events, they ensure coherence. If Atlas was part of such a synchronization, then its true meaning lies not in us alone, but in the timing shared with others we cannot see. A cosmic event we thought natural may in fact be the metronome of galactic communication. The unsettling implication is that we might not be the audience at all. Atlas may have been aimed at Earth, but Earth may not be central. The synchronization may be with something else entirely, a pulsar, a merger, a galactic cycle. We are incidental observers of a broader event. Our role may be peripheral, yet meaningful nonetheless. The visitor draws us into a rhythm that is not ours, but we cannot help but feel part of it. Synchronization works because it creates the illusion of inclusion. Even if we are not the target, we are caught in the pattern, and the pattern makes us care. Ultimately, synchronization blurs the line between chance and design. Coincidences can be dismissed, but repeated coincidences that align with rhythms demand attention. Atlas arrived not in isolation, but in context. Context of our technology, our culture, our cosmic environment. Whether by design or by chance, it became synchronized with multiple layers of meaning. That synchronization may be illusion, but illusion does not weaken its effect. Perception is reality in communication, and synchronization ensures perception. If the cosmos communicates, it may not do so with words or signals, but with timing. Events synchronized across scales we barely perceive. Rhythms we're only beginning to recognize. Atlas may be one beat in that rhythm, fleeting yet unforgettable. Its true message may not be in its chemistry or its orbit, but in its timing, its synchronization with us, with our tools, with our readiness. Cosmic synchronization events may be the hidden language of the galaxy, waiting for us to notice, and once noticed, we will never again see silence as empty. When astronomers first analysed the coma of 3I Atlas, the data seemed to whisper of something out of place. Most comets in our solar system release water vapour when warmed, with carbon dioxide and carbon monoxide contributing in smaller amounts. But Atlas inverted the ratio. Carbon dioxide dominated to an extent never observed before, overwhelming water and leaving astronomers puzzled. At first, the explanation was framed in terms of natural diversity. Perhaps Atlas formed in a colder region than any of our comets, preserving volatile carbon dioxide while water remained locked away. Perhaps it was ejected early from its system, carrying chemistry we had never sampled. These are sound scientific ideas, but to others the anomaly raised a stranger possibility. Could chemistry itself be the act of summoning? Could an interstellar visitor carry not just atoms, but intent encoded in its composition? The idea begins with the universality of chemistry. Wherever matter exists, chemistry follows rules that are invariant. The spectral fingerprint of carbon dioxide is the same here as in distant galaxies. Hydrogen's emission lines are constant, recognizable to any observer with instruments. This universality makes chemistry an ideal candidate for communication. If one wished to send a message across stars, one could embed it in ratios of gases, in isotopic abundances, in combinations that defy natural processes. The message would not be words but numbers, carried not by sound or light but by molecules themselves. To summon attention, chemistry could suffice. Atlas's dominance of carbon dioxide may be such a summons, not message in the sense of language, but signal in the sense of emphasis. By exaggerating a chemical signature, the object ensured notice. Astronomers could not ignore it. The data forced new models, demanded explanations, created debate. That is the essence of a summons, to call attention, to provoke focus. Whether intentional or not, Atlas achieved it. Through chemistry alone, it summoned humanity's curiosity. This raises a broader possibility. Perhaps all interstellar visitors are not just debris but carriers of chemical messages. Some may display anomalies in ratios, others in isotopes, others in unexpected compounds. Each anomaly could be chance, or each could be designed. If designed, then the chemistry itself is the beacon. Unlike radio signals, which fade and require decoding, chemical signatures persist, immune to distance once delivered. A comet's coma becomes a broadcast of molecules, readable by any civilization capable of spectroscopy. Chemistry becomes the medium of the message. Skeptics argue that chemical diversity is expected. Star systems differ in composition, in temperature, in formation history. To expect all comets to resemble ours is parochial. Atlas may simply reflect another environment, yet even skeptics admit that extreme anomalies provoke attention. That is the point. Intentional or not, unusual chemistry functions as signal. It summons precisely because it defies expectation. In a galaxy filled with natural variation, exaggeration becomes indistinguishable from design. The result is the same. Observers cannot ignore it. Consider the possibility of encoding information through isotopes. Ratios of carbon-12 to carbon-13, or oxygen-16 to oxygen-18, can reveal formation conditions. but they can also be manipulated. A probe disguised as comet could carry isotopic ratios impossible in nature, pointing unmistakably to artificiality. We have not yet measured Atlas's isotopes in such detail, but future interstellar visitors may force the question. If a comet arrives with isotopic abundances wildly outside natural ranges, the case for summoning through chemistry will be undeniable. The molecules themselves will testify. There is also the possibility of complexity. Natural chemistry produces simple molecules: water, carbon dioxide, methane, ammonia. Life produces complexity: amino acids, nucleotides, proteins. If an interstellar visitor carried complex organics in abundance, beyond what random processes allow, it could function as summons, not communication in the sense of dialogue, but in the sense of provocation. Humanity would not dismiss such a discovery. It would transform our understanding instantly. The chemistry would summon not just curiosity, but a new world view. Atlas did not reveal such complexity, but its strangeness points toward the possibility. If future visitors escalate the anomalies, showing progressively more elaborate chemistry, the case for design will grow. Each one becomes a step, a sequence of summons through chemistry, drawing us deeper into awareness. First, anomalous ratios, then unusual isotopes, then complexity beyond abiotic processes. A progression designed to ensure attention without overwhelming, to guide curiosity step by step. If this is design, it is subtle, patient, cautious. Chemistry becomes both language and leash, leading us forward carefully. Another perspective comes from history. Humans have long associated chemistry with summons, even if unconsciously. Alchemists sought messages in elements, believing transformation of matter revealed hidden truths. Chemists of the 19th century saw periodicity as cosmic order, a structure inviting interpretation. Biologists view DNA as the ultimate message, written in molecules carrying instructions for life. In each case, chemistry was not neutral but communicative. Atlas fits into this lineage, summoning our attention not through sound or sight, but through its chemistry. It continues a tradition older than science itself, where matter is message. Skeptics warn that such thinking risks overinterpretation. To see communication in chemistry may be projection. The universe is full of anomalies, and most have natural explanations. Yet the counter-argument is that communication must work with universals, and chemistry is universal. If intelligence exists beyond Earth, it would surely understand that molecules carry meaning. To use chemistry as summons is not anthropocentric, it is pragmatic. The question is not whether chemistry can communicate, but whether we can distinguish natural diversity from deliberate emphasis. That distinction may define the next century of astronomy. The possibility of summoning through chemistry also intersects with panspermia. If comets can deliver molecules to planets, then interstellar visitors may carry life's building blocks deliberately. Atlas may not only summon attention but also contribute material. Its dust may fall into Earth's atmosphere, seeding new chemistry. We may never know whether those molecules originated naturally or were chosen, but the effect is the same. Chemistry becomes not just summons, but influence. The line between communication and delivery blurs. The molecules themselves are both message and medium. From a cultural perspective, chemical summons are powerful because they feel objective. Numbers on a spectrum cannot be dismissed as illusion. Ratios are not ambiguous. They're as concrete as physics allows. Yet interpretation remains flexible. We may see anomaly and think coincidence, or we may see anomaly and think design. Chemistry summons not by providing certainty, but by provoking the choice. Do we explain it away as chance, or do we suspect intention? Either way, we are summoned into reflection. That is its power. If Atlas was natural, then its chemistry is a reminder that the universe is richer than we expected. If Atlas was designed, then its chemistry is a signal meant for us. Either way, chemistry has summoned us. It has forced us to look, to measure, to debate. It has drawn us deeper into awareness of interstellar visitors, ensuring that the next one will be studied even more carefully. Summoning through chemistry may not be proof of design, but it is proof of effect. Atlas has already succeeded in that sense, whatever its origin. The larger lesson is that the universe may not speak in words. It may not send clear signals or direct broadcasts. Instead, it may summon through anomalies, through chemistry, through the quiet insistence of molecules that do not fit our models. Atlas was one such summons. The next may be stranger still. Each will call us to attention. Each will force us to expand our understanding. Each will test our willingness to entertain possibilities. The chemistry is the summons, and the summons is enough. The question that lingers after 3i Atlas and its strange chemistry is not only whether it summoned us, but what happens if we answer. Curiosity has driven us to study, to measure, to speculate. But curiosity is not neutral. Every observation we make, every radar ping, every transmission bounced against a passing object is not just information gathered, it is information sent. To us, this feels harmless, part of the scientific process. But in the broader frame of the cosmos, such acts may carry risk. An answered call is never simple, never free of consequence. For decades, scientists have debated the wisdom of messaging to extraterrestrial intelligence, or METI. SETI, the search, is passive. METI is active. It broadcasts signals deliberately, declaring Earth's presence to anyone who might be listening. Advocates argue that any civilization capable of hearing us is already aware of Earth's biosignatures, oxygen in our atmosphere, radio leakage from our technologies. Broadcasting simply acknowledges what cannot be hidden. Critics argue the opposite. They warn that silence is safety, that announcing ourselves in a universe we do not understand could be catastrophic. Between these poles lies uncertainty, and into that uncertainty steps every interstellar object we study. When radar beams sweep across a comet like Atlas, they scatter into space. When radio telescopes transmit calibration pulses, they echo beyond Earth. These signals are not powerful enough to reach across the galaxy intact, but they travel nonetheless. In the near-cosmic neighbourhood, they may be detectable. If Atlas is natural, nothing changes. If Atlas is artificial, then those beams may have been heard, noted, logged. In that moment, we answered without meaning to. The risk is not abstract. It is immediate. Every act of science becomes an act of exposure. The risks of answering depend on assumptions about the nature of intelligence beyond Earth. If the dark forest model is correct, then silence is universal policy. Any voice is beacon, and beacons attract attention. In such a forest, to answer a summons is to invite danger. The call may be genuine, or it may be bait, but the risk is the same. Once answered, the sender knows where to find you. The danger may not arrive in decades, or even centuries, but the exposure is irreversible. We cannot recall a transmission once it leaves. The risk is permanence, yet refusing to answer carries its own risks. If a summons is genuine, silence may be interpreted as failure, disinterest, or even hostility. A civilization attempting cautious first contact may expect acknowledgement, some sign of awareness. If none is given, they may move on, deciding Earth is not ready or not willing. In that case, the risk of answering is danger, but the risk of not answering is isolation. The choice is not between risk and safety. It is between risks of different kinds. Atlas intensifies this dilemma because it embodies ambiguity. If it were obviously artificial, we could decide whether to respond. If it were clearly natural, the question would not arise. But in uncertainty, we are forced to act without clarity. Every observation we make may already be an answer, whether we intend it or not. Every silence we maintain may already be interpreted as response. We are caught in the paradox of communication. To act is to risk. To refrain is also to risk. The only certainty is that risk cannot be avoided. The history of human contact offers sobering parallels. When isolated civilizations encountered one another on Earth, the outcomes were rarely equal. The more technologically advanced often overwhelmed the less prepared, even without intent. Diseases spread, resources were exploited, cultures were transformed. To answer a call across stars may repeat this pattern on cosmic scale. Even if those who summoned mean no harm, their presence may destabilize us, overwhelm us, alter us irreversibly. The risk lies not only in predation but in disruption. But human history also shows the opposite. Encounters have brought exchange, enrichment, and survival. Ideas, technologies, and cultures have merged to create new possibilities. The risk of answered calls is not only negative, it carries potential for transformation that may be beneficial. The danger is that we cannot predict which outcome will prevail. Once answered, the path is irreversible and control is lost. That loss of control is perhaps the deepest risk of all. There is also the question of intent. If Atlas was summoned deliberately, then the senders already know we exist. They timed the arrival for our readiness, ensured visibility, perhaps even designed anomalies for us to notice. In that case, answering may not add danger. It may only confirm what is already known. But even then, risks remain. Confirmation could trigger escalation, leading to more direct encounters, more intense scrutiny. Each step deepens entanglement. Each step increases vulnerability. Risk accumulates, even when contact is cautious. Some argue that answering is inevitable. Humanity is not a silent species. We broadcast unintentionally through every act of technology. Our cities radiate in infrared. Our communications leak into space. Our spacecraft leave artifacts behind. To imagine that we can remain silent is illusion. In this view, the risks of answering are not new. They have always been with us. Atlas only sharpens awareness of what has been true for a century. We are already visible. The question is not whether we should answer, but whether we should pretend we have not already done so. Yet inevitability does not erase responsibility. Even if exposure is unavoidable, the manner of answering matters. Reckless broadcasting may invite risk unnecessarily. Careful, measured observation may minimize it. The challenge is deciding where to draw the line. With Atlas, we crossed it unknowingly. By probing its coma, by broadcasting radar, by publishing results globally, we answered whether or not we intended to. The lesson may be that answering is not a decision made once, but a constant process, one embedded in every act of exploration. The risk is not an event, but a condition, ongoing as long as we look outward. The cultural weight of this risk is heavy. It shapes how we think about ourselves and our place in the cosmos. Are we explorers, willing to answer any summons despite danger? Or are we guardians, cautious and silent, wary of exposure? Each identity has appeal, each carries cost. Atlas forces us to confront this choice more directly than ever before. Silence is no longer default. Answering is no longer optional. Every anomaly, every visitor, every act of curiosity becomes part of the dialogue, whether we want it to or not. From another angle, the risk of answered calls may itself be the test. Perhaps visitors like Atlas are not threats, but examinations. The summons is chemical anomaly. The answer is our behavior. Do we respond with reckless broadcasting or with cautious study? Do we unify globally or fragment into suspicion and denial? The risks we take reveal our nature, and that revelation may be what others seek. The risk is not only ours, it is theirs as well, for to summon is also to expose. In this sense, answering is mutual. Both sides risk. Both sides wait to see what the other will do. Ultimately, the risks of answered calls cannot be eliminated. They can only be managed. Every act of science, every observation of visitors like Atlas, is already an answer in miniature. The The challenge is to decide how far we will go, how much we will reveal, how boldly we will engage. Perhaps silence is no longer possible. Perhaps the call has already been answered. In that case, the only question left is what comes next, and whether we are ready for consequences we cannot control. What if we were heard? It is the question that lies beneath every debate about SETI, about interstellar visitors, about the silence of the skies. For decades we have wondered whether anyone listens. But in the wake of Oumuamua, Borisov and Atlas, the deeper possibility emerges. What if our signals, our transmissions, our curious responses have already been received? What if somewhere in the galaxy, a record of humanity already exists, not in myth or imagination, but in the archives of another civilization? The thought is disorienting because it forces us to step outside our sense of isolation. We tend to assume that our transmissions vanish into emptiness, scattered into the void. In practice, radio waves fade, signals weaken, and distance devours energy. But if advanced civilizations exist, their instruments may be orders of a magnitude more sensitive than ours. What is faint to us may be clear to them. What we believe lost may be archived. Our first broadcasts of the 20th century, music, speeches, military communications, may already be catalogued elsewhere. They may know us not from deliberate contact, but from the incidental leakage of our technology. In that sense, we have already been heard. But the arrival of interstellar objects complicates this picture. If Atlas or others like it were deliberately sent, then being heard is not passive, but active. Our response to these visitors, turning instruments toward them, bouncing radar off them, publishing findings globally, becomes evidence of our awareness. They may already know our atmosphere contains oxygen, that our planet radiates heat. What they could not know until now is that we can notice them. That shift is profound. To be heard is not just to be detected. It is to be recognized as capable of recognition. And once that happens, the relationship changes forever. What if we were heard and our response was seen as reckless? Radar transmissions sprayed outward, curiosity unrestrained, exposure casual. Would another civilization interpret that as boldness or as naivety? Would they see us as promising or as dangerous to ourselves and others? Hearing us may not mean embracing us. It may mean evaluating us. And evaluations carry consequences. What if we were heard and our silence was noticed instead? Perhaps Atlas carried anomalies designed to provoke communication, but we gave none. To us, this may be caution. To them, it may be refusal. What does silence say? Is it wisdom or is it apathy? Does it show discipline or does it suggest indifference? In a universe where communication is perilous, silence can be both shield and barrier. If we were heard in our silence, we may already have been judged, even if we never know how. The unsettling part is that being heard does not guarantee response. Civilizations may archive our signals without revealing themselves. They may evaluate us without contacting us. They may watch us for centuries, deciding whether or not we are safe, whether or not we are worth engagement. Being heard does not mean being answered. It may mean waiting under observation, aware of possibility but never certain. Silence may follow, not because no one exists, but because they have already heard enough. If Atlas was a summons and we answered, then somewhere a record of our answer may already exist. Perhaps instruments far beyond our imagination captured the radar echoes we sent. Perhaps archives now hold a detailed map of our detection networks, a measurement of our patience, a record of our caution and our recklessness. If so, then the act of hearing is complete. Humanity has already been catalogued. We may not yet see the consequences, but the record is made. The future will unfold with or without our awareness of how it began. The possibilities that follow are wide. If we were heard by a civilization older and wiser, they may wait until we are ready. If we were heard by a civilization cautious and fearful, they may avoid us indefinitely. If we were heard by a civilization hostile or competitive, the risks become darker still. The unsettling truth is that we cannot control interpretation. We can decide what we send, but not how it is understood. Once heard, we are no longer authors of our story. We are characters in someone else's. History offers parallels again. When isolated cultures on Earth first became known to others, their fate was rarely in their own hands. Sometimes they were ignored, left to develop quietly. Sometimes they were exploited, reshaped, even erased. The difference depended less on what they said and more on how they were perceived. The same may now be true of us. If we have been heard, then perception by others determines our future more than our own intent. That imbalance is the most unsettling risk of all. But being heard may not be threat. It may be opportunity. If we were heard by benevolent intelligence, then our existence is already known, our presence acknowledged, our awareness confirmed. Silence may not mean rejection, but patience. They may wait until we reach thresholds of stability, unity, or maturity. Being heard may place us under observation not for harm, but for guidance. Perhaps the summons of Atlas was not lure or trap, but invitation, one that will remain open until we are ready to walk through. Even if no intelligence lies behind Atlas, the fact remains that our actions echo outward. We are heard by the universe itself, if not by others. Every transmission, every spacecraft, every artifact on the Moon or Mars becomes testimony to our existence. To be heard is to be written into the cosmos. Our challenge is to decide what we want that record to say. Reckless curiosity, cautious silence, or something in between. Whatever we choose, it will define us long after we are gone. Being heard is not a choice, it is a condition of being technological. The question is not whether, but how. And so we return to the original question. What if we were heard? The answer is that we likely already have been. By radio leakage, by atmospheric signatures, by our responses to interstellar visitors, humanity has already spoken. Whether anyone listened is beyond our knowledge. Whether anyone judged is beyond our control. But we cannot undo what has been done. We are part of the conversation now, whether we wish to be or not. The only uncertainty is what will follow, and whether silence that endures is absence, or the pause before reply.